as well. Of course, we are being recorded. So I see that we are now live streaming on YouTube. So Mr. Brock, could we go on the record, please? Good morning. This is the 5th day of evidentiary hearings in Vineyard Wind's petitions before the Energy Facilities Siting Board and the Department of Public Utilities in dockets EFSB 20-01, D.P.U. docket 20-56, and D.P.U. docket 20-57. Are there any preliminary matters to address before we move to our examination of the company's witnesses on the topic of substation noise?
Ms. Sharkey, I think the staff had decided amongst ourselves that we'd like to start on just finish up onshore construction noise associated with the duct bank and splice fault construction.
Okay, thank you, Mr. Hazel. Then let's move on with those questions.
Good morning, everyone. I have just a handful of questions related to onshore construction noise. I'll ask the question and anyone who knows the answer may answer. Can the company enlighten me about the nighttime construction activities for the onshore construction portion of the project?
I can start with that, and perhaps Mr. Butler might want to get into it. So I think the only place right now that we expect to do some nighttime work going in is the crossing of Main Street or Route 28 partway up the route, and that's a relatively busy road. And based on our experiences with the first project and conversations with the town and DOT, we expect to have to do that in a couple of steps and likely do that as evening or nighttime work. And so the basic construction activity is no different than during the daytime, but because of the traffic volumes, it can be done much more efficiently in the evening and nighttime hours. And the nearby land uses in that particular crossing are primarily commercial on the four corners of the intersection. There are some residential properties a little further away. And this would be an activity that would be accomplished within a matter of by time you factor in setup, cleanup, et cetera, probably certainly within a week.
And so what is the specific activity that is related to the construction that would be happening at night?
Okay. Well, if in fact we did everything after hours, it would be essentially the same process as the daytime work. So you would start with setting up traffic control measures, which in this case would be to keep one lane of the roads open. Then you would do saw cutting so that you could, well, there's some pavement marking first, then you would do saw cutting. Then when you're ready, you remove the existing pavement, excavate the trench that you need to place the duct bank. And in this case, assuming we're coming from the south, you would work your way out to the midpoint of the crossroad so that you can keep traffic moving in one lane on that. And then you would install the once it's excavated, you would install the plastic sleeves, backfill with sort of a low strength concrete. Once that's set up, you would do whatever other backfilling and compaction is necessary, and then probably plate it over temporarily until you're ready to do the temporary pavement. So assuming you got all that done, say in the first night, then the second night you would come back and do it from the other. You do the other half of the road and continuing up the. And then when that's done,
I'm sorry, continuing up the
route, and then you would do the temporary paving that we talked about the other day as quickly as you could. After that, take down the traffic management controls and move on from there.
Thank you. Does the company anticipate needing or requesting any approval for the nighttime construction?
Well, we've made clear in this particular instance that we are going to do that at night. So we would certainly let the town, let DOT know, and I'm sure that would be reflected in our road opening permit when we get to that point. Now, there is the possibility that, for reasons we don't foresee right now, that it would make sense to do some nighttime work elsewhere, and in that case, we would clearly discuss that with the town and get their acceptance well ahead of time. So,
thank you. Is the company aware of any bylaws within the town of Barnstable that pertain to construction-related noise?
I might start the answer perhaps, and Mr. Barton can elaborate. The draft EIR in section 10.8 has a nice little discussion about that. But in summary, it does say that the town of Barnstable does not have any bylaws applicable to construction noise. That's really the short answer, I think, to your question.
Okay, thank you. Thank you for the reference.
Sure.
Please refer to EFSB-NO-18. Well, I'll give you a moment to get there. While the company acknowledged that splicing activities would not occur on Saturdays, does the company anticipate any other construction activities that might occur on Saturdays?
I would say this far out, we do not, but there's always the possibility that as more detailed construction planning and traffic management planning is done and discussions are held with the town, there could be an instance where it would make sense to work on a Saturday in front of a particular location as opposed to a weekday. So with that caveat, we do not expect to work on Saturdays on any routine basis.
Apologies, but just to be clear, was that question relating to onshore construction activities in the roads in Barnstable?
Yes.
And Mr. Barton, is that how you understood the question?
Yes, my answer was that's what I was speaking to.
Thank you.
Do any of my colleagues have any questions related to the, construction activities that might occur on Saturdays, or how the company might have, talked about their construction activities?
I do have one follow-up question. The witnesses described the potential for construction outside of the normal work hours related to the Centerville River crossing and the Route 6 crossing?
So I can start that, and others may want to chime in, but I think for the Centerville River crossing, assuming we do that by the technique that we discussed the other day, most of that is more or less normal construction activity, set up, excavating the receiving pits on either side, bringing the equipment to do the microtunneling, doing the microtunneling, et cetera. And unlike a few of the HDD activities that we talked about the other day, that once they're started need to be finished in one motion, the microtunneling can proceed on a kind of a normal shift basis. So barring something unforeseen, we would expect to do that work within a normal construction work schedule.
I don't think I could call up the exact reference in the record, but I think the company has described the potential for encountering like large obstructions in the Route 6 crossing, like large boulders or something like that. If the company were to encounter, large boulders during the Route 6 crossing, would that be a circumstance that would or could require work outside of the normal hours?
I mean, it could, but I don't think there's that it's necessarily required. I mean, if you started to advance the Route 6 crossing by microtunneling, and you came across a significant obstruction, well, it depends in part on how significant the obstruction is, but assuming it's something you can break up and remove, you could do that during normal work hours and proceed with the plan.
And I would just add to that the reference to the potential for encountering large boulders in the Route 6 crossing. It partly stems from our conversations with Mass DOT early on about their experience constructing Route 6, the presence of some surface boulders that were removed during the installation or the construction of Route 6. And it's for that reason, in part, that we've advanced and proposed the microtunnel approach as opposed to an HDD, because a microtunnel approach allows for sufficient workspace within the construction shaft for those boulders to be removed. But that process is not time sensitive in as much as it wouldn't require that to be done overnight or on the weekends. That work could, as I understand it, could be done during normal work hours and work schedule.
Thank you, Mr. Rodstrom. I'm all set with the in-street portion of noise construction. Ms. Yellen, if you had anything further, go ahead.
I think I have one question. If I could refer the company to the analysis volume 1 at page 5-88. I have a quick question about the construction hours proposed for the onshore construction in general and the landfall site. I just wanted to hear from the company as to why they're slightly different. And let me know when you're ready to answer the question. It's at page 588.
So just to start, what we describe here is that for installation of the onshore duct bank and cabling, construction is anticipated to occur during typical work hours, parens 7 a.m. to 6 p.m. Monday through Friday. Then it makes with the caveat that there could be exceptions where some work be required outside those hours. For the HDD construction at Craigville Beach, we talk about basically working 7 a.m. to 7 p.m. Monday through Saturday, with the caveat that the conduit pull-in has to finish once it starts, which we talked about the other day. So we are on somewhat of a more constrained schedule for the HDD work because of the likelihood that we'll have a time of year restriction related to the piping plumber, and we also have an agreement with the town that we will be out of that parking lot by, I believe it's May 15th. So that may in part be the thinking behind a somewhat extended schedule, but one of my colleagues may be able to expand on that.
I may add a little bit to that. There's also a difference in the actual construction process we're referring to here. While onshore duct bank construction, it's relatively easy at the end of the day to leave the trench box there, put plates over the road, and secure it and not worry about anything changing overnight or over a weekend. Where the HDD, you're drilling a bore path and you're using the bentonite slurry and you're setting up an annulus under the seabed. It's preferable to continue that as much as you possibly can, knowing that we can't work around the clock all the time for that process. Ideally, you would want to just work around the clock, but understanding that's not a possibility for us, you don't want to leave that for long periods of time without the full borehole secure and drilled. So that's part of why the longer hours, to get as much of it as you possibly can done and not the long extended periods of time, like over a whole weekend, leaving the borehole, exposed and not fully finished at that point.
Thank you for your responses. So if I'm understanding correctly, the town has also requested no work on Sunday, or was that just that the company decided that Sunday would be fine if it didn't have to work on that day? I could rephrase that. I understand from Mr. Aruta's response that it would be ideal to work around the clock. So are the current hours proposed as 7 to 7 Monday to Saturday stipulated by the town, or is that something else?
I would have to refer to my colleagues of where that originated. I think it was more of a compromise of working and taking the neighborhoods into consideration here and trying not to work on a Sunday, if at all possible, but there may be more background that others on the panel can provide.
I think we would have to check, but my sense is that this in all likelihood followed the agreement, if you will, that was developed in the course of Vineyard Wind 1, albeit for a different beach parking lot, but the same the same principles. So I suspect we had a 6-day-a-week schedule for Vineyard Wind 1, and we carried that over to Vineyard Wind 2, but we would have to check that to be certain.
So I guess that would be a record request response, if that's the best way to do it. Ms. Sharkey, you're muted.
Mr. Wong, could you just repeat the,
Could the company let the board know where the providence of the 7 to 7 Monday to Saturday schedule for the landfall site is?
that would be record request EFSB 29?
Thank you. I'm all set.
Can the company please elaborate on, the differences between the noise impacts, compare the noise impacts between the preferred route and the noticed alternative route, please?
I could start off that I believe the major difference in noise impacts would be just the difference in the length of the onshore construction route, and that the preferred route is the most direct path from landfall to the project substation, and therefore in the aggregate that the amount of noise impacts would be less than the alternative that would take a longer path to the project substation from the landfall. So I think that would be the major difference, because I think the landfall landing technique, the Centerville River crossing, and the Route 6 crossing methods are all very similar.
And just if I might to add a bit to Mr. Rodstrom's answer, the alternative route is roughly half again longer than the preferred route. So that basically means you would have, all other things being equal, you would have construction activity going on for an additional 50% more days than the preferred route. And it's not a huge difference, but there are somewhat more residences along the noticed alternative route.
Okay, and while I understand that the preferred route has less noise impacts than the noticed alternative route, there are still noise impacts with the preferred route. And can the company please explain what noise mitigation techniques will be implemented for the preferred route?
Sure. So and this answer really applies to duct bank construction in general, whether it's on the preferred route or the noticed alternative route. So we would start with some basics of making sure that the contractor equipment was in good repair, properly functioning mufflers, things of that nature. To the extent that there are compressors required for some parts of the work, use a quieted compressor. And then I think beyond that, basically doing the work in an orderly, organized manner so that you can move as quickly and efficiently as possible through a given neighborhood or past a given home. There's no way to do this work without some amount of equipment and excavator dump trucks, things of that nature, and they can only be quieted to some extent. So the real way to do this and hopefully minimize the noise impact on nearby residences is to do it as quickly as you can safely. And Mr. O'Neill might want to elaborate on that a bit.
Yes, there's some additional discussion about general thoughts on noise control during the in-street construction process in the information requests, both N06 and N07. But to summarize, it's part of the strategy, of course, is to use the quietest equipment that's available from the contractors. The company would consider using portable walls, if it's needed in certain circumstances. And in general, as discussed in NO-7, there are not a lot of receptors along the primary route that are normally occupied on a full-time basis during construction work hours. But that being said, the company would still consider, any requests for mitigation on a case-by-case basis.
Thank you. Just for my own knowledge, portable walls, how much would portable walls mitigate? Like, would that be, if something was emitting 80 decibels of noise, how much would a portable wall, how successful is that as a mitigation measure?
Sure, no, that's a good question. Their sound attenuation characteristics for these portable walls are relatively modest. I mean, it's certainly a visual screen, which for a lot of us sometimes not seeing the construction equipment is some benefit there. But generally, if you get 5 to 10 decibels of mitigation from a portable noise barrier, that's about all you could typically expect. So if you have an 80 decibel source, you might get it down to 70 decibels. So the neighbor's still going to hear it, but it will be reduced.
Okay. Well, thank you.
Welcome.
That concludes my questions for the onshore portion of construction noise. If my colleagues have any other questions, feel free to ask.
Mr. O'Neill, are there any specific circumstances that the company would be amenable to using construction or portable noise barriers? Or maybe, actually, hold that. Maybe the reverse of that question is more useful. Are there any scenarios where the company can't use portable noise barriers for the in-street construction?
I could certainly start the answer, but I'd probably defer to Mr. Arruda or Mr. Rodstrom to elaborate, or Mr. Barton. There certainly can be, certainly for safety considerations, access around the equipment. For noise control, you would prefer to put a barrier as close as possible to the source of the sound. But in construction activities, of course, that's sort of a two-edged sword. You put it too close to the source of sound, there are certain real safety concerns there. So there has to be that balance on safety, getting the job done in an efficient, timely manner, because there is time involved to set up these things, take them down, which then prolongs the period of construction. So that sort of goes against trying to get in and out as quickly as possible. But perhaps my colleagues could elaborate on some other reasons that you or occasions where you wouldn't want to use portable sound barriers.
I would agree with Mr. O'Neill. It's a little impractical to consider the noise barriers during some of the duct bank installation work. As he said, you got a lot of equipment that's moving. And in order to set these up and still give the workroom that those pieces of equipment would need, and for the various workers to work safely around this, it's just impractical to think that the noise barriers could go up for work when you have excavators going back and forth around a trench and people working around an open trench. And this trench and this work is continuously moving, having to pick up noise barriers and move them along in a manner that would really be beneficial seems a little impractical.
Are there more stationary aspects of in-street construction where a portable noise barrier might make a little bit more sense? I'm thinking about maybe the splice fault installation or the cable splicing itself.
I would agree, Mr. Hazel, that would be probably the most practical part of the construction process where noise barriers could be beneficial, because you really have equipment that is stationary. You have people working within the vaults at that point. So you could set up some noise mitigation and reap the benefits of it during the splicing activities.
If I could just add I would note that the splicing activities themselves would, largely take place within the vault, and that the noise generated from that activity is less than the construction of the duct bank or installation of the vault. And just to add to my colleague, Mr. Ruda, I think in the in-road construction portion of the project, we're going to be balancing safety, obviously traffic impacts and mitigation in a fairly constrained area, and having a visual barrier to the construction zone where there's still active traffic flow, heavy equipment in and around, could also create some safety issues in the in-road portion, as opposed to perhaps down at the landfall location.
Thank you for the helpful context. I think we're ready to move on to the substation noise, the operational substation noise, if my colleagues are all set with the in-street construction portion. Okay, so I'm going to lead the question on substation operational noise. And to get us started, I just have like a basic question about when the substation actually generates noise. This might be a little bit of a naive question, but is the noise generated by the substation sort of proportional to the cable loading or the output from the wind farm?
So once and Mr. Ruda will probably want to add to this, but once the substation goes into commercial operation, it essentially runs 24/7 for the life of the project, and it's the noise generation that we've talked about occurs to some level continuously.
So if the wind farm is at zero output on a totally still day, there's still equipment in the substation that needs to run, and that equipment will still generate noise, even if they're not, transforming voltage, or I don't know. I guess I was just trying to understand if there's any circumstances where the substation would not make noise, or if it is indeed pretty steady during the commercial operation.
I would agree with Mr. Barton's explanation of the noise. Once the wind farm is energized, it is pretty much energized for the entirety, unless there's a major maintenance event where you have to take a circuit out of service. Because keep in mind, when there is no wind and the wind farm is not generating electricity, it needs electricity from the system to keep power out to the wind farm for all the ancillary equipment at the individual wind turbines and the offshore substation. So the offshore wind farm is always energized. So that equipment, whether it's producing power or using power, is pretty much a similar occurrence.
Oh, thank you, Mr. Aruda. That's helpful. Moving on to the noise modeling assessment submitted for the draft EIR. I'd like the witnesses to describe the relationship between the L90 and the LEQ exceedance levels, which are used in the noise modeling assessment.
I can certainly start with a general discussion of that. Is there something specific, Mr. Hazel, in the draft EIR, or a certain table that you're looking at? Or are you looking for more of a broader answer on LEQ versus L90?
I guess I think I'm looking for a more broad answer. My confusion or the question stems from looking at table 7-1, where it presents the L90 and then comparing that to table 7-6, where the modeled sound levels are presented in an LEQ. And I just want to, I think I get the relationship between L90 and LEQ, but I just want to make sure I'm thinking about those two terms correctly.
Oh, absolutely. It's a real subtlety, but there's a small distinct difference. The L90, as everyone I'm sure knows, is the definition of background here in Massachusetts. So that L90 really represents the quietest 10% of your period of time, whether it's 10 minutes or an hour or whatever it is. The LEQ is the equivalent sound level, again, over some specified period of time. So if you're looking at an L90 and an LEQ over an hour, for example, that equivalent sound level would be the sound level basically integrated over time. So if you have a very variable source of sound, that LEQ takes all the energy over that period of time and comes up with a one number equivalent for it, hence the LEQ or equivalent sound level. In the case of this project, I'm getting to, I think, the applicable answer here. The case of this project where you're looking at these components of the substation, as my colleagues have said, once the substation is energized, it's going to run. And these components are very steady. So our experience in measuring sound from substations is that when you look at the L90 and the LEQ, they're almost identical. There's very little variation because the sound from a substation is generally very steady. So those two numbers are virtually identical. The reason we present both of them in the technical analysis is because the state of Massachusetts requests the L90 as their definition of background, hence we present that. But the vendors, the suppliers of all the equipment, the international standards that they all use to measure sound and provide sound data are in the form of an LEQ. So our sound models are done using the LEQ data from the vendors. So the sound modeling output is in terms of an LEQ, but we then compare it to an L90 background in Massachusetts.
That is very helpful. Thank you.
You're welcome.
On the topic of the L90, I believe that the L90 represents background noise. And can you explain whether the L90 value for a particular location would vary seasonally, or what does the L90 represent as presented in the DEIR? Is that a L90 for a particular season or for the whole? Is it meant to be representative of the quietest time for the whole year?
So in this case, we have figure 7-4 in the draft EIR. You don't necessarily need to go to it, but that provides the detail on the L90. And we measured the L90 during the month of January. So my limited Cape Cod experience suggests that the middle of January on the Cape is a quieter time of year, not as active, of course, as the Memorial Day to Columbus Day. So the intent here, Mr. Hazel, is that we measured it during a quiet time of year. Therefore, these L90 backgrounds represent what I would suggest are very conservative background levels, that if we'd gone back in June or July and done the same measurements, we would have gotten higher L90 background sound levels.
Maybe this goes beyond what you're comfortable with, but could you offer a professional judgment of like how much higher you think an L90 would be if it was measured during the summertime?
I'll give you all the usual caveats that a scientist and engineer would give you, and say this is certainly an educated guess based on experience, certainly in measurements in other seasons for other projects. But we will often see a variation of at least 5 decibels between a summer and a winter background. And certain hours of the day, you'll see even more than 5 decibels. Could be a 10 decibel difference during certain hours of the day, such as peak traffic hours, for example. But I would say conservatively, at least 5 decibels difference is what I would expect.
And can you explain a little bit about how the background noise, the ambient background noise in a particular area affects a receptor's perception of a noise source? What's the relationship between the source of the noise generating equipment, the background noise, and how the receptor hears the interaction of those two things?
Great question. There's a lot of layers to that. First of all, of course, the sound levels we're talking about these are exterior sound levels. These are levels measured outside. And the L90 values that we're using in this analysis to form the basis of our evaluation are the very quietest hours. So those are at 2 and 3 o'clock in the morning. That's what's in the analysis to do the comparison. So most people at 2 or 3 in the morning are inside their homes. Sound levels are much different, honestly, than they are outside. So there is somewhat of a disconnect between what we're measuring outside and what we hear inside during those same hours. Again, if you look at the L90 plot here in figure 7-4 of the EIR, you'll see that during the daytime, the L90 at the locations around the substation for the project are 50 to 60 decibels. So that's a very different sound environment than at 2 and 3 o'clock in the morning. So you're going to have a very different, I'll call it an acoustic experience during the day versus at that 2 or 3 a.m. period as well. So something you might hear at 2 a.m. if you're standing outside on your deck and you can't sleep, you might hear something at 2, but during the day you're probably not even going to notice it due to the different sound environment.
Gotcha. So I think it's that last part that I wanted a little bit more explanation of, is if the ambient sound level is higher, why is it that a particular noise source may be less noticeable to a receptor?
Sure. So because the sound level from the substation in this case is constant 24 hours a day, as we've heard from our colleagues here. So whatever the sound level was modeled at someone's home, let's call it 40 decibels for sake of discussion. If that sound level is 40 decibels, it'll be 40 decibels at 2 a.m. It could be 40 decibels at 2 p.m. So it's the same either time, but if you're outside at 2 a.m., you might notice it. At 2 p.m., if the sound level from traffic and everything else going on is 60 decibels, it's going to be masked. So you're not going to notice it. It'll just blend right in with the background, not be perceptible.
Okay. So if earlier you indicated that in the summertime, it could possibly be the case that the L90 would actually be, as much 5 decibels higher than in the winter time. So would it follow through that in the summertime, the noise contributions of the substation would be maybe a little bit less noticeable than in the winter time?
That's exactly correct. That's true. Yes.
Okay. And another concept that I think you touched on was the whether a person is inside of their home or outside of their home, and you indicated that the noise modeling for this case was these are all exterior sound levels. So can you describe a little bit about the sound attenuation that would occur for being inside of a structure?
Absolutely. There's really two ways to look at it. One is, are your windows open? Nice weather in the summer, or are your windows closed? With windows open, the literature is pretty clear that any construction here in the Northeast, you're going to have at least a 10 decibel reduction, anywhere from 10 to 15 decibel reduction in the sound levels from outside your house to inside your house. So a sound that's 40 decibels outside would be 25 to 30 decibels in your house. If the windows are closed, that reduction is even more significant, and the literature says it's 20 to 25 decibels of reduction from outside to in. And at that point, whatever you've got going on inside the house is going to be louder than outside.
And when you say literature, are you referring to peer-reviewed engineering journals, or just sort of your past experience as an acoustic engineer?
I would say both. The US EPA did some great studies back in the 70s, which I suggest will still hold true. So the US EPA levels document, which is a well-known document in our field, has that detailed data in it. But in addition, we've done plenty of our own measurements over the years that have borne that out.
I am interested to see the US EPA levels document. So I'll issue a record request that the company submit the reference document that Mr. O'Neill referred to, and point us to a point in that document where it discusses the noise attenuation benefits of being indoors and also of having your windows open versus closed.
So that would be record request EFSB 30.
I have another record request queued up, and this is for a specific type of map that I would like. So I think I'll just go right into my next record request. To set this up, I think it would be helpful if the company referred to EFSB NO 14. There's a set of really helpful maps attached to NO 14, which show a radius around the landfall site, and then highlighting each structure within that radius, and saying what the distance from the noise source is. And I'd like the company to prepare a similar map, but for the substation. And I would like that map to use a radius of 500 feet from the substation property line. So the buffer radius is 500 feet, and then
I'm sorry, so the what radius is 500 feet?
The buffer radius is 500 feet. And then if the map could identify all of the structures inside of that buffer with the specific distance from, if it's possible, from the nearest noise source on the substation.
Mr. Hazel, I'm sorry, are you really interested in what the substation sound level, the modeled sound level, would then be at each of those structures as well? Or are you just looking for a map of structures and distances out to 500 feet?
If it's possible to provide the modeled noise levels, in addition to the map that I described, that would be, I would be interested in that. Yes.
And we can certainly do that. The way I might suggest it's most encompassing, it might give you the information you're looking for, is to take the contour sound level map, which we already have in the record, and overlay that on the map you're talking about. And then you can go to any structure and just look at the contour map and pull up the sound level value at that location.
Yeah, I like that idea. We'll amend the record request to include the detail that Mr. O'Neill described.
And if I might, not to put too fine a point on this, but if I think left to our druthers, we would take those distances from the substation fence line, which corresponds to the property line in all but the south side of the substation, where there's that sort of triangle of land that extends out onto the right of way where nothing is happening. So I think probably a more representative way to do this is from the fence line as opposed to that southern property line, if that's okay.
That would be acceptable. Thank you, Mr. Barton. Good suggestion.
Thank you.
So with those clarifications, that would be record request EFSB 31.
Could we go off the record just a moment?
Off the record?
I have a small technical issue. It'll just take me about a minute. Thank you.
Back on the record?
Okay, still on the topic of substation noise. I have a couple questions on the revised substation design that was proposed in exhibit VW-10. In the supplemental response to EFSB NO 29, the company presented a table of noise modeling results indicating that if it increased the wall height by 5 feet, it could sort of maintain the same levels as were presented in the DEIR. And then subsequent to that supplemental response, I asked the company to sort of present a more detailed analysis where they reran the noise modeling. And that resulted in the memo, which is RR-EFSB-4 attachment 1. Do the noise modeling results in the record request 4 in any way supersede or replace the noise modeling results presented in NO 29S?
So I will start the answer, and perhaps my colleagues can expand on it. the sound modeling results that you see in record request EFSB 4, table 1, those are the sound modeling results that we would expect under the addition of that second parcel with the footprint lowered by 10 feet. So those are very similar, although not identical, to the sound level modeling results in EFSB NO 29, the table there.
And both of those include the increased wall height on the western edge from 30 to 35 feet. But I think the most current results that we have for the substation as currently envisioned, which is with the grade lowered, is in record request EFSB 4.
Thank you, Mr. Barton. Back to NO 29, the supplemental response. The company indicated that it may be necessary to add internal sound walls to offer additional mitigation. And I was just wondering if I'd like the panel to elaborate on what was meant by adding internal sound walls in that response.
So I can start this, and Mr. O'Neill may want to elaborate, but I think we were trying to leave the door open to say, you know, if we found a particular issue, be it with ambience or pure tones, there might be some tweaking required to the wall designs that are part and parcel of this, and it, not only the big the big wall that goes around the StatComs on the west side of the site, but there's a whole series of barriers around the transformers and other major equipment. Those walls serve several purposes, but one of them is noise control. And we did, in fact, and when we answered the record request number 4, if you look on figure 1 that accompanied that, you can see that we did incorporate a short additional sound wall down at basically the southeast corner of the site, a 10-foot sectional wall that is, you know, on the order of 100 feet long, and that was added to deal with a particular pure tone issue that we had identified in that more refined modeling.
Yes, Mr. Barton has described it exactly as what I would have said, Mr. Hazel.
Can you describe a little bit more detail about why the 10-foot wall in the southeast corner of the substation was added? Mr. Barton alluded to a pure tone issue.
It really comes down to the fact that with the 10-foot reduction elevation, that means that the relative heights of the sound sources versus the receptors have changed a little bit. You know, the geometry of them has changed. Therefore, it was added really to account for a pure tone issue, to reduce the sound enough from certain octave bands to eliminate the pure tone. That was the thinking behind adding that wall.
Okay, I think one item that I noticed changed between NO 29 and record request 4, which record request 4 includes the short 10-foot wall, is I think the noise levels at modeling location K changed, which modeling location K is on Cranberry Lane, southeast of the substation. Are you familiar with that observation, or is that, did I miss the mark on that?
On table 3 of the record request number 4, we're showing basically for that receptor K, we're showing a 6 dB increase over that late night ambient. And that's for the current modeling, and that was also where we were with the modeling done for the DEIR.
Okay, I see. Thank you. I just have a question about kind of the level of detail that the noise model is able to incorporate. And elsewhere in the record, the company's talked about leaving a 30-foot vegetated buffer strip along the western boundary of the substation. Is the noise model able to account for the presence or absence of vegetation around the substation?
So technically speaking, we could put in a small amount of reduction from vegetation, but we do not. We do not, in our modeling practice, we do not take credit for that, even if it does exist, which again helps us feel better about our modeling results being conservative. And again, if it's a pretty modest stretch of vegetation, you're not going to get, honestly, a significant level of sound reduction from that. It certainly acts as a nice visual screen, which does help, but you're not going to get a significant sound level reduction. We don't take any credit for it.
And in this case, if I might add, I think that kind of goes double, because we have that 35-foot wall down most of the western edge of the site, and the vegetated buffer you're talking about would be on the western side of that wall. So the principal noise attenuation is really coming from the wall, and the vegetation is, I think, as Mr. O'Neill properly characterized, is a nice visual screen, but it's really not going to serve any noise reduction purpose in this case.
Okay, that's helpful. Thank you. In response to EFSB NO 23, the company indicated that it would install noise barriers at the substation constructed with precast concrete panels. Can you describe a little bit about how the noise barriers are actually constructed? I'm trying to picture how a concrete panel is different from, say, a cinder block wall or something like that.
I'll get started on the response, and others can elaborate. The idea of precast panels is those are generally made off-site, and they can be trucked in and installed within the I-beams or whatever methods of supports are in there for the panels, as opposed to, for example, you mentioned a cinder block wall, which you would then obviously construct on site. But the advantage of doing a wall type of construction is, of course, there's less chance for gaps or openings in it, which would compromise the sound level reduction capabilities of it.
So you sort of indicated there's a steel I-beams that might be installed, and then the concrete panels are kind of maybe slid down between the I-beams, and so the concrete panels are actually making up the most of the solid portion of the wall. Am I picturing that correctly, do you think?
Absolutely. That would be the walls, the concrete panels are the noise reduction technique here. And keep in mind, this is not to mean this is exactly what Vineyard Wind is going to install at this location, but they are representative of the type of construction that you would reduce the noise by that type of amount.
Did the company propose concrete panels for their noise attenuation properties, or was that more from like a practical engineering construction priority?
Some of both. Certainly the concrete type of panels give you a good deal of noise reduction. That's a great characteristic of them, significant noise reduction because of the mass. There's also all kinds of, this is where I'm getting a little bit out of my league, but all kinds of fire protection considerations around a substation. So you don't want to have a nice little wooden barrier there, for example. So there's other reasons to use concrete and things like that, which perhaps my colleagues could elaborate on what they use at other substations.
I think Rob hit the high points on that, and the one other thing to bear in mind is that at least for the barrier along the western edge, it's 35 feet tall, so there obviously are some structural and wind loading issues that need to be thought about in building that kind of a wall. So the I-beam design with channels or slots, if you will, to insert the concrete panels is a very robust way to do that. I can't imagine that you would attempt to build a 35-foot wall concrete out of concrete blocks. That would not have the right strength.
I think, along highways or other places where noise barriers are used, I personally have observed like wood being used as a sound barrier. Mr. O'Neill indicated that wood might be less preferable from like a fire safety standpoint, but can you describe whether it has different noise attenuation properties?
Sure. Once again, a concrete type of barrier panel would be superior to almost any type of wood that you would propose, even if wood were acceptable from a safety perspective. The concrete is going to give you better noise reduction than wood.
Okay. Also in NO23, the company referenced a different type of material that could possibly be used for the noise barrier. And it's a bit of a mouthful, but I'll give it a go. Prefabricated glass reinforced thermoset composite panels. Those could also be used for the noise barrier. And I'd like the company to comment on whether the prefabricated glass panels would provide any additional noise attenuation compared to precast concrete.
I think before somebody starts on that too, we should point out that I think what this meant to say was prefabricated fiberglass reinforced. So
yes,
we'll go with fiberglass. That's much easier to say on the record.
Right, and they would not be clear like window glass. It'd be fiber.
Okay.
I'll start the response here. That part of the discussion in the response was generally saying that there is other technology that could provide a similar sound level reduction. In other words, what we assume in noise control is that whatever panel, whatever obstacle you put between your source of sound and the receptor or the resonance is dense enough or massive enough that the sound is not going to go through it. That's the real key here. You're going to force the sound to go up and over it, which is why you build these things, in this case, 30 to 35 feet tall. And the more you force it to go up and over, the greater your sound reduction is. So the thinking here was that this fiberglass reinforced composite panel is not necessarily going to get you any better sound level reduction, but it could be equivalent sound level reduction because there are products on the market that can be built with enough density in them that you can get the same type of transmission loss through the panel, which is what you are trying to achieve here. So whether it's concrete or this composite panel, you're going to get a similar level of sound at the neighbors. That's not going to change the answer there. It's just we put that out as an potential alternative technology. The drawback is they are much more expensive.
Keeping the wall height at assuming the wall height is at a similar level or the same level, is the company aware of any other materials that could offer better sound attenuation than precast concrete?
No. At this point, that type of material is effectively limiting the transmission through it because it's so massive, and whatever sound is occurring offsite is only occurring because of sound going up and over the barrier wall.
So for at least the wall portion of the sound mitigation, the only way to further reduce the noise from the substation, at least for the receptors to the west, is it to make the wall taller?
And we looked at that question exactly, and just so you know, the heights that were proposed in the draft EIR, those were arrived at after many iterations of sound level modeling. You know, we started with a modest height. I can't remember exactly what we started with, and then we keep going up in height as you continue to see benefit. So in other words, if we go from 10 feet to 15 feet, we see a significant drop. We keep going. We try 20 feet, same thing, 25 feet. Once we reach about 30 feet here and you start adding height, there becomes a point of diminishing returns, and that's what we've reached here. And I think the record request EFSB NO29 elaborates on that, where there was a request to look at a wall that was 35 feet tall as opposed to the 30-foot tall wall. And as you can see from the table in that response, the changes were either 0 or 1 decibel from adding an additional 5 feet. So you reach the point of diminishing returns, and a change of an additional 1 decibel is imperceptible to us as people.
My understanding of NO29 would be that the 35-foot wall for a substation that's 10 feet lower provides the same benefit as a 30-foot wall for the substation that's at the same elevation of Chute Flying Hill Road. So it seemed like Vineyard Wind had to increase the wall height just to maintain the same noise increase that was modeled for the original substation design. Did I misconstrue what the company was trying to communicate in NO29S?
I think that's the gist of it, and that to the extent we're seeing changes as you adjust the grade and the wall height. They were basically 1 decibel at a handful of the receptors, not necessarily, interestingly, the closest receptors. And as Mr. O'Neill said a minute ago, at 1 decibel, you're in the range of imperceptible to the human ear.
So it sounds like, well, I guess for the lower substation elevation, the revised substation design, is the company saying that increasing the wall height beyond 35 feet has no additional benefit?
That is correct.
I'd like to ask a record request that the company, just to help convince me, you know, if it's not too much trouble to submit the modeling with a 40-foot wall and, you know, provide the results to demonstrate whether or not there is a diminishing return.
That would be record request EFSB 32. Would this be a good time to take our morning break, Mr. Hayes?
Yes, please. Thank you.
All right, we'll be off the record and back at 11:30. back on the record.
Thank you. Still on the topic of substation noise and generally looking into various mitigation options. So we've spent a little bit of time talking about the main sound barrier along the western boundary of the substation. There are several other noise barriers on the site and even a few internal noise walls. And has the company looked at whether increasing the height of those other noise barriers would have any effect on mitigating the ambient noise level increases?
So I'll start, but once again, we start with a modest size barrier. It's sort of the minimum height to block the sound, and then we go up from there to understand where you reach the point of diminishing returns. As I understand it, and I might look for one of my colleagues to expand on this, that some of these three-sided walls that are interior to the main wall are also blast walls, which are in there for other reasons. So if, perhaps somebody could expand there.
Yeah, but we did go through an exercise of looking at some varying heights, and I would point out that there actually are 8 three-sided enclosures incorporated into the design around the 6 transformers and a couple of reactors over on the eastern side of the site. There are also 4 buildings, 2 of which house switchgear and 2 of which house the STATCOM units. So there are a number of internal structures that are helping with noise control. There is some practical limit on how high you can make the enclosures, the three-sided enclosures around the transformers, because if they get too high, they start to interfere with the bushings and cabling that are at the top of those units. But nonetheless, what's in here are pretty substantial structures. And then, as we discussed earlier, we did add that additional small 10-foot noise wall down at the southeast corner of the site.
So looking at the eastern portion of the site, I'm not sure which piece of equipment these are, but they're immediately east of the 345 GIS building, and they're proposed as a 20-foot wall. Are those equipment enclosed by the 20-foot wall a significant noise source on the site?
So those pieces of equipment are the iron core shunt reactors. Figure 7-5 in the draft EIR has a very nice labeling system, which is very helpful in terms of visually seeing which pieces are which. And those iron core shunt reactors are one of the lower or least noise emitting sources amongst the group. That information is shown in tables 7-3 and 7-4 of the draft EIR. That's another reason that the wall, you don't need as tall a wall down there, because that's not one of the major sources.
And oh, I see. Thank you for referring to me to figure 7-5. So there's also 2 150 MVA iron core shunt reactors. are those similarly low noise emitting?
Correct.
Okay. And then what about the 450 MVA transformers?
So those are one of the more significant sources amongst the sources there on the site, which is one of the reasons that you needed a 30-foot wall as opposed to a 20-foot wall.
So since the 450 MVA transformers, they're a little farther away from the main western sound wall, and it sounds like you get the best benefit for the wall that's closest to the actual equipment. So would increasing the height of the wall, the three-sided walls around the 450 MVA transformers have any noise attenuation benefit?
It really not likely. As I said, we did iterate the height of these walls until we reached the point of diminishing returns, or as Mr. Barton said, there are limitations due to the wires and the bushings at the top of them. There is a certain physical limitation. You can't go much higher, but my recollection of the modeling is that this was about where we topped out, that you're not going to see any more benefit from raising the wall beyond 30 feet. Not for those particular walls, no.
Is it possible that for the lower substation elevation, increasing the wall height to 35 around the 450 MVA transformers would have some material benefit to noise attenuation from the substation?
I would say it's unlikely, but we would have to check. And I so would defer to Mr. Aruda perhaps, and whether a 35-foot wall is even physically viable around that size transformer.
I can't confirm 100% whether it would even be viable without, if some of those heights are determined by the actual manufacturer of the specific transformer. But you do reach those limitations, as Mr. Barton said, where you physically will start to encumber the ability to get the bus work out of the transformer over to where it would connect into the 345 kV GIS.
Okay, I'd like to ask a record request that for the revised substation design, which is 10 feet lower, that the company assess whether raising the height of the three-sided walls around the 450 MVA transformer, what effect that would have on the noise receptors assessed in the DEIR. And for that modeling check, I'd like the company to also use the same 35-foot wall along the western edge of the substation, just so that kind of have a consistent comparison with record request 4. And as a second part to that question, I'd like the company to state whether it's feasible from a engineering perspective to increase the wall height to 35.
Is the company clear on the record request?
Yes, that's
Yep.
clear.
In that case, that will be record request EFSB 33.
I'm looking at figure 7-5 of the DEIR still. And I have a few questions about the buildings that are proposed on the substation. So let's start off with the StatCom buildings on the western side. Are the StatComs enclosed in structures for noise attenuation purposes or for engineering reasons of needing to have sort of like a controlled environment for that equipment?
So Mr. Aruda may want to elaborate on this, but I think it's primarily the latter, to protect the equipment that's contained in that. There are other elements of that whole StatCom installation, a step-up transformer. There are some air core shunt reactors and a bank of cooling fans. That equipment is all of necessity outdoors. So the building is limited to a portion of the StatCom installation. But Jack, I don't know if you want to elaborate on that.
No, I would agree with Mr. Barton. There's a certain portion of the StatCom that requires that it has climate control and needs to be indoors, but there's another part of the overall StatCom that must be outside for cooling purposes, and it wouldn't be practical to have it inside of a building. So it's a combination of both, where you have some in controlled environment and some of it that needs to be outside.
I'm looking at table 7-3 of the DEIR, which provides the sound power levels for equipment in the substation. And I'd like the witnesses to let me know which equipment in table, sorry, let me rephrase my question. Table 7-4, are all of these pieces of equipment in table 7-4 located inside of the StatCom building?
No. So as I mentioned in my previous comment, the step-up transformer, the air core, shunt reactor, and the cooling fans are all outside. And if you look back at figure 7-5, you can see the yellow block essentially is the building. And then the cooling fans, the cooling fan bank, which is on the outside, is, I'm looking at the southern unit, is closest to the wall to the south. And then the air-cooled shunt reactor, or air core shunt reactor, is just to the north of that. And then the transformer a little further to the north with a 3-sided enclosure around it. And
is it possible to put an additional 3-sided enclosure around the air core shunt reactor? And if so, would that provide any benefit?
I would suggest no, just from a noise point of view. I don't know if it's technically feasible or not. But if you look at table 7-4, you can see that the air core shunt reactor is 77 dBA sound power level, which is well below any of the other major noise sources. And that's already benefiting from the 30-foot wall, which is immediately adjacent to it.
And I would also point out that, for example, over on this side of the site, the 2 step-up transformers that come with the 2 STATCOM units have 3-sided enclosures around them, which does provide some noise control benefit. But the primary reason that those 3-sided enclosures are there is an outgrowth of an agreement with the town and code for fire protection reasons. So the noise benefit is it's there, but it's not the primary reason why those enclosures are there.
And then the actual buildings themselves for part of the STATCOM equipment. Do those buildings offer some noise attenuation for the equipment that's located inside?
They would, and our typical approach for buildings is that the buildings are assumed to be robust enough that the noise contribution of whatever is inside the building is controlled to a point where it's not significant for modeling purposes.
And just to expand on Mr. Barton's answer, that is true. And in this case, whatever sources are inside the STATCOM building are very minor to begin with, even before you take any credit for reduction of the building itself.
Okay, so figure 7-5, it looks like the STATCOM building also has a label HVAC associated with it. And on table 7-4, the HVAC units have a broadband sound power level of 88. So, I'm not totally clear if the HVAC is inside of the building or outside of the building.
That's going to be outside. It's a normal type of compressor that you might see at your house, outside your house, on a pad, a cooling condenser to keep the building at, as Mr. Arruda said, there are some climate control requirements. So the HVAC is there. As you can see, it's proposed to be located on the eastern side of the building, so you get some additional reduction from the building itself before it even gets to the 30-foot wall.
Mm-hmm. So I guess, before I leave the topic of noise walls and buildings, I'll just ask a broad question of whether there's any other places or opportunities on the substation site to add additional noise barriers that would offer mitigation for the off-site receptors.
I'll start, and perhaps my colleagues can add to the answer. I think the answer, Mr. Hazel, is no. As you can see, there's already 8 3-sided barriers proposed, as well as 2 additional general barriers around the different pieces of equipment. And these really are targeted to the significant noise sources. Going after other sort of more minor noise sources will not change the sound levels off-site. Really, for noise, as I'm sure you want to approach it in a top-down manner, going after the loudest sources first, and that's what we've done for this application. So they've all been targeted with noise barriers. So I would answer that no, any additional barriers are not going to provide any meaningful benefit offsite.
Mhm. And I just have a sort of a general question about the revised substation design, which is 10 feet lower. Can you describe how the relative position of a noise source and the receptor might change based on lowering the substation by 10 feet?
I'll give it a try. So it's geometry, of course. It's line of sight. So the model is trying to take wherever the source is, and basically draw a ray, a ray, RAY, towards the residence offsite, wherever you're trying to model it. So if you drop that elevation 10 feet, then of course the elevation of that source drops 10 feet. Excuse me. And so that calculation can, depending on the direction you're looking at, it can generally be beneficial, because now the terrain is on one direction could be 10 feet higher than it was before. So often it's somewhat beneficial, although in another direction it may be slightly less beneficial. I think we saw that with the table of results in record request number 4. But it's a geometry exercise. So if you drop the elevation 10 feet, the model just recalculates everything at 10 feet lower.
So for receptors, the modeling locations A and D, which are the 2 residences to the west of the substation, is there a more direct line of sight between the substation and those structures as a result of lowering the substation by 10 feet? And when I say line of sight, I mean, the opportunity for a ray of sound to travel from the source to the receptor.
I would almost have to get into the model and look at it in 3 dimensions to truly answer your question.
I think I'll give you the opportunity to do that, and I'll ask that question as a record request. I'm happy to restate it. The record request is for the company to investigate how lowering the substation by 10 feet changes the potential for sound from the substation to reach receptors D and A located west of the substation.
So could I ask a question on that? I think to get at what you're looking for, we'd have to dig into the model with the 30-foot western wall. In other words, drop the elevation, hold everything else equal, and then look as well at the 35-foot wall. And that extra 5 feet was added in part to keep things the same for some of the receptors.
So, Mr. Barton, how are you proposing that the record request be modified?
I think it's fine like you ask it. I'm just pointing out that that's probably how we would go about. There'd be kind of a 2-step answer.
Okay, that's acceptable. I think I understand what you're getting at there, and that would be a helpful response to have on the record.
So that will be record request EFSB 34. Mr. Barton, I just wanted to, before we got too much further afield, I wanted to ask you about a statement that you made with regard to the 3-sided enclosures around the STATCOM units and you said the primary reason for those enclosures was because of an outgrowth of an agreement with the town and code for fire protection reasons. So could you expand on that answer to tell me what you meant in terms of the agreement with the town specifically, and the requirement for fire protection code reasons?
When I made that statement, I was talking specifically about the three-sided enclosures that are around the two transformers, one for each of the STATCOM units. And those, like the other transformers, have a certain amount of dielectric fluid in it. And in the course of the first project, the town of Barnstable had some very specific thoughts and requirements on basically the containment system for transformers, both the containment underneath the transformer as well as the use of three-sided barrier walls. So that's primarily what I was referring to. And agreement may have been the wrong choice of words there, but basically it's an understanding that has been reached with the town in terms of how containment is to be provided for that type of equipment.
And I guess I just wanted to determine whether, for example, that type of detail would be something that was in the host community agreement, or more just an understanding between the town and its regulatory boards and the company.
From my own personal knowledge, I can't say whether that has found its way into the host community agreement, but the appropriate town offices have certainly made their feelings known and are understood by the project.
And I might add, the host community agreement speaks to it at a higher level, meaning that we will work cooperatively with the town on secondary containment issues, and come to an agreement on, a final design, and take their inputs into consideration on the final design for the substation. So that's the basis for that, what Mr. Barton spoke to.
Thank you, Mr. Arruda.
Okay, the next topic I wanted to pursue was the selection of the actual equipment used at the substation. I believe in the DEIR and in part response to EFSB -NO-24, the company indicated that the noise modeling was conducted using typical substation equipment rather than the specific substation equipment that would be used in the instant case. Can you give me just an overview again of why the company feels it's appropriate to use sort of typical equipment rather than the specific make and model that would be used for this substation?
So let me start that, and then Mr. O'Neill or Mr. Arruda may want to add to it. So obviously we're still a couple years away from being at a point where the project can start to buy equipment. So when we say we've used a general set of information as opposed to a specific purchased piece of equipment, it's because we're not in a position to purchase anything at this point. But under the category of general equipment, we have looked very carefully at the kinds of equipment that we're likely to buy and that have been built into the model. So as discussed on page 7-11 of the DEIR, the major sound sources, the 450 MVA transformers and the like, start with the assumption that you're purchasing a low noise variant of a transformer as opposed to your standard off the shelf model, if you will. And then in many instances, there is some additional noise control built into the modeling consideration. So basically we're saying that, you know, we would go to the manufacturer and say, so we like the quieted transformer, but we want some additional noise attenuation baked into that design. And that's what's outlined on page 711. So we're not at the point of saying, you know, page 4, Model X in the catalog, but we have gotten into specifics on the noise characteristics of the equipment. And in every case, this equipment represents a considerable quieting over, quote, standard equipment. And that was guided in part by the work that has been done on the first project where we're building a similar scale substation, not exactly the same equipment because the ratings are somewhat different. But we've had the opportunity to sort of look at the realism of these choices and have that to rely on as well.
I appreciate that the company, you know, looks to, you know, lower noise emitting pieces of equipment. I mean, are there any opportunities to take it a step further and you know, really find the lowest noise emitting piece of equipment to use for this substation, or does the company believe this is sort of the limit of how quiet substation equipment can be?
I could expand a little on Mr. Barton's reply, if I could. You know, I think the process of selecting the anticipated noise levels for the equipment and using that in the model, that was done quite closely with our Vineyard Wind Connector 2 engineering and EPC team. And I think when we're looking out, as Mr. Barton suggests, a couple of years from now, at the point that we would be procuring the equipment, I think we need to kind of maintain these levels as targets, because it's not only the specific and specifications of the equipment, but also the availability and supply of that equipment, and making sure that it can be delivered on time and on schedule. And so at this point, it's I would say a little early in the process to be narrowing down to any specific vendor or a model of equipment. But as that process proceeds and we get closer to that date, it can be more precise and fit within the anticipated project schedule.
I guess I'll just restate my question. Is the company aware of any equipment variants that would be lower noise emitting than what was used in the model?
Let me take a shot at that. The answer is, as we understand it now, is no. In other words, as Mr. Barton said, you know, we started with quieter equipment, and then the company was greatly informed by the procurement process it recently went through for Vineyard Wind 1, where they did talk to, you know, actual suppliers who can make this equipment, and they asked for, you know, all the noise reduction bells and whistles that they could get on that equipment. And that informed us about the reality of how low we could go in the modeling here. So this is aggressive. This is very aggressive in terms of the sound power levels that we're showing in here in the modeling. You know, I've done a lot of modeling of transformers, and 93 decibels sound power for a 450 MVA transformer is extremely quiet. So we feel very confident, comfortable that in terms of what's commercially available out there from companies that can make this and supply this in a timeline that's going to meet the company's goals, that this is as quiet as we can get.
I guess to sort of wrap up at least this part of the noise questions on mitigation options, are there any other forms of noise mitigation that we haven't discussed today that are, on the table to, take down the substation's noise impacts by even a, small margin?
So to reduce sound, there's really two ways to do it. You either got the quietest equipment you can do, so you control it at the source itself, which I think we just finished talking about. And the company has got on the table the quietest equipment that they feel they can commercially procure right now. Or you can control the path of the sound off the site, which are the noise barriers that we've been talking about this morning. So those are really your two tools in the toolbox to reduce offsite sound. And I will go back to the point that we did make earlier in the conversation today about the comparisons that we're talking about here are to just 1 or 2 quiet nighttime hours in January. Really, the impacts that we're talking about are much less reduced for most of the rest of the year and most of the other hours during the days and evenings. So I don't want to get too focused on just the +2, +6, +7 from that table. Those are true numbers, but they really are occurring at a very short percentage of the time outside. So I think to answer your question, Mr. Hazel, there really aren't any other options that the company hasn't explored for either reducing the sources themselves or reducing the path of noise transmission off-site. This is a very robust noise control program here.
Just another general question about the kind of noise that a substation makes. Are the witnesses able to offer any qualitative description of kind of what a substation sounds like? Whether it's akin to a white noise machine or a humming noise, or an entirely different character of noise from equipment. Is that something the witnesses could offer a verbal description of at this time?
Certainly from my field visits to substations of a variety of sizes, I think your characterization of white noise is probably a good one. Assuming that the potential pure tones have been addressed, then what you're left with is basically white noise. And I mean, I can think of, certainly I've made a number of visits to the Lower SEMA substation, which is another 345 kV substation, not too far away. I've been there during the day, and I would say that every visit that I can recall, the traffic noise from Route 6 was what I heard. I mean, I could stand at the fence line as close as a civilian can get, and I could not, from my ear, say, that's a transformer hum or that's a reactor hum. What I heard was traffic noise from Route 6.
Mm-hmm. Thank you, Mr. Barton. Do any of the other witnesses have anything to contribute to that description?
I would concur with Mr. Barton's observations. I've had similar experiences.
Okay. Another follow-up question on just kind of the character of the noise coming from a substation. Earlier, the witnesses testified that a substation has a fairly constant, steady noise coming from the equipment on site. Is it possible that under either high load or high temperature conditions, there would be more fans running on various fans associated with transformers or the cooling racks north of the StatCom buildings or south of the StatCom buildings? Are any of those features variable with the capacity or load being managed by the substation?
I would say that's a fair characterization, Mr. Hazel, of how the substation will operate. There are occurrences at higher loads during warmer weather. You may have additional fans running or, cycling on and off on various pieces of equipment. But I'll defer to Mr. O'Neill. I think a lot of that was taken into account in his modeling, the noise from those pieces of equipment actually operating.
Mr. Aruda is correct. For example, the 450A power transformers, the biggest sources there, they do have a few different modes of operation where they have either cooling by airflow or cooling by one set of fans or two sets of fans. And the hottest days or the hottest operating conditions will have the most fans running to cool the transformers. And that's the highest sound power level. That's what we assumed in the modeling as the worst case. So your hottest conditions, your highest temperatures, which again goes to the fact that there could be other days where that particular source of sound could be several decibels quieter. The same thing with the cooling bank fans at the StatCom building. Those are cooling related. They're not going to run all the time. The HVAC unit of the StatCom building, the same thing. But we assume that every one of those pieces was running as if it was the absolute worst day you could think of on the Cape.
Okay. Thank you. Thank you for clarifying that, Mr. O'Neill. That's helpful.
You're welcome.
I'm gonna transition to compliance with the DEP noise policy. If any of my colleagues had any follow-up questions on sort of the equipment or configuration of the substation, it might be good to ask those before I move on to the noise policy. Okay. Seeing none, I guess we can press on. The DEIR at page 7.4 refers to a particular section of the DEP noise policy which pertains to new noise sources and adjacent land uses. Can the company please elaborate on why it believes the modeled noise increases for the properties to the east of the substation are acceptable under the Mass DEP noise policy?
Could I just ask a quick clarification, Mr. Hazel?
Sure.
When you refer to east of the substation, is that specifically referring to, for instance, the Chamber of Commerce property, or further east from that?
For the moment, I'm referring to east of the substation and south of Chute Flying Hill Road. So I think there's the triangle parcel, which the company may acquire. And then next to the triangle parcel, there's land that I believe is owned by MassDOT. So for the purpose, is the company clear about which parcels I'm referring to?
Yes, that's helpful.
I'll start the answer. So, in my 35 years of working with DEP and the noise policy, they look at they do look at the land use. And for example, in this case, where the land use is right now, it's not being used for anything, and Mass DOT is the land owner. There's nothing sensitive there. The DEP is less concerned about sound levels from that, given the use today. And I guess the triangle parcel might be a slightly different category because the company has an option on that to get it under their control. But generally, in that case, the DEP is really going to focus their attention on residential use and properties that are going to be noise sensitive.
On the next page, 7-5, the second paragraph describes, quotes from the noise policy. And I think the final sentence seems to indicate that if a property could be developed for residential land use in the future, noise mitigation might be required. You see that the final sentence of the second paragraph that I'm referring to?
I do.
So I believe in response to EFSB-NO-22, the company indicated that there's no known conservation or deed or title restrictions that would prevent those properties from being undeveloped, specifically the MassDOT property from being developed at some point in the future. So I'd like the company to describe more about how the substation design complies with that final sentence of the second paragraph.
I think if you look at figure 7-6 in the draft EIR, that has the sound level contours from the proposed substation. And you can see what the expected worst case sound levels could be in the direction of the parcels I think you're talking about, Mr. Hazel. And so clearly that MassDOT parcel is a very, very large parcel. One does not know today where, if MassDOT was somehow to sell that for a residential land use, which is obviously a leap, but if they were to, you don't know where any residential use would go. Generally, the sound levels in the middle of the parcel are 45 decibels or less. On the east side of the parcel, they're predicted to be 40 decibels or less, which is going to, if I have to look back at the table for a second at the other parcels. It's going to give you sound level impacts not dissimilar from modeling location B or D, where you've got a +7 or +8, perhaps, if someone went that route.
I see. Is the company aware of any natural resources or wetlands or anything like that on the MassDOT property to the west that would hinder the possibility of being developed in the future? Perhaps from it's sometimes called a desktop level analysis of resources on a property.
Mr. Hazel, just a clarification. I believe you're still talking about the MassDOT parcel to the east of the substation.
Excuse me, yeah. That's exactly the parcel I'm talking about.
I could start. I think the company's not aware of any mapped resources that are that would affect potential development. However, I would say, as Mr. O'Neill mentioned, the addition of the triangular 1 acre parcel that the company has optioned and would develop for a new access road, that entire parcel would be added to the overall substation land area, not the fence line, but the land area, and would limit some development of the site in the vicinity of that triangular piece. So that would create, in a sense, some limitation on any development.
Is the company aware of how the MassDOT parcel to the west is zoned? Maybe you would know that just from doing sort of the zoning analysis for the substation itself. And then as a follow-up to that question, is it possible that any zoning designations for the MassDOT property would hinder or prevent residential developments on that property?
I would have to check, but I do believe it's zoned residential. And I would also say a limiting factor is that there's no sewer in that part of town, and so there would be a limitation on any septic systems or sewage for any use on that property. So I think that's what we know at this point.
And if I understand it's somewhat of a hypothetical, saying like, if MassDOT sells the property and it's developed for residential use, would the company consider adding noise mitigation along the western boundary of the substation at that time if those conditions were realized?
And I apologize again, Mr. Hazel, but I believe you probably meant the eastern boundary.
Yes, I'm sorry. I should just refer to it by its address. I believe the address of that property is 15 Shoot Flying Hill Road.
So since we're kind of engaging in hypotheticals here, another path this could take is if MassDOT decided that property was surplus, which would be the first step toward them doing anything with it. My understanding is that they then need to notify other state agencies that they've made that designation, and it's possible that another state agency would raise their hand and say, well, we would like that for XYZ purpose. If there were no takers at that level, then my understanding is that they would put the property up for sale on an auction basis. So there would be nothing to preclude Vineyard Wind from competing in that process and perhaps buying the land as a piece of buffer. And again, this is strictly hypothetical, but that could end up making more sense than allowing it to be used for some other purpose and then trying to retrofit noise control on the eastern side of the site, Although, as Mr. O'Neill pointed out, the contour modeling that we do have tells us that we're within the 10 dB increase that would be allowable under DEP policy in any event.
For the majority of the property, it looks like some of the property would be above 10. I believe the property line noise increase is above 10.
That very well may be. Presumably, if someone went to the trouble to develop that parcel for residential use, there are all kinds of setback rules. They couldn't be building right along the property line anyway. But that being said, there is a little sliver there that might be plus 10.
Has the company had any discussions with the property owner of 15 Shoot Flying Hill Road, who I understand to be MassDOT, regarding the modeled noise increases on their property?
I think I could answer that. The company has engaged with discussions with Mass DOT in the past about numerous aspects of the project, including the Route 6 crossing and Route 28 crossing, the Centerville Bridge. So we have had discussions with the district office about that, and we have had discussions with the real estate and other office within the Mass DOT about that particular parcel and exploring the process Mr. Barton was describing. So they're very much aware of our plans and intentions for the substation site. But we never specifically addressed that question about the noise impacts, and nor was it raised by the state.
Is it the company's intention to engage in a conversation, with MassDOT as an abutting landowner, just to make them aware of the expected noise increase, even though the property is presently undeveloped?
I would say it is the company's intention to kind of maintain an ongoing communications with Mass DOT about all the aspects of the project, including the substation site, and we could certainly inform them of the noise issue or the noise from the substation site during those conversations. Yeah.
Thank you. And then a similar line of questions for the Chamber of Commerce property, and I'm referring to the Chamber of Commerce property north of Shoot Flying Hill Road, which is receptor F in the modeling assessment. Has the company met with and discussed with the Chamber of Commerce about the expected noise increase for the Chamber of Commerce building across the street from the substation?
Yes, I could answer that. We have had numerous conversations with the Chamber of Commerce staff about the proposed project, specifically addressing the modeled noise levels, as well as clarifying for our purposes and for the purposes of our filings with the Siting Board and with MEPA, the nature of the activities at the Chamber of Commerce facility, being mainly daytime office use, the location of where any public activity occurs, which is actually on the north side of the Chamber of Commerce property, furthest away from our substation, and did communicate directly about the anticipated model noise emanating from the substation. So I would say it's fair to characterize that they have been they're aware of the proposed project and all those details.
Did the representatives that the company discussed this with express any concerns about the noise increase from the substation?
No, during our conversations, there was not any concerns raised by the chamber.
And I understand that, you know, these communications could have happened in a face-to-face meeting or a phone call or something like that, but does the company have any sort of record of, you know, conversations about the noise increase at the Chamber of Commerce building that that it could provide to the board to support your characterization that the noise increase was discussed and that the Chamber of Commerce was, you know, essentially okay with it as you characterized?
We certainly have notes from the meetings we've held or communications with the chamber, and but I would have to check about the specific detail of those and whether those are reflect this subject.
Okay, yeah, I'll issue a record request, and that would give the company a chance to look back at your notes. And what I'm looking for are any, you know, written communications or, you know, meeting minutes, things like that, between the company and the Chamber of Commerce, specifically in regard to the modeled noise increase that the Chamber of Commerce might expect during the operation of the substation. And as a second part of that same question, whether the Chamber of Commerce expressed any concern about the noise increases and how the company intends to address those concerns of the chamber.
That would be record request EFSB 35.
I think I might have a few questions after I have the opportunity to converse with my colleagues. But I think I'm at a point right now where I would pause on this topic. I don't know, we're a little early for our normal lunch break, but I don't know if any of my colleagues have noise questions or perhaps any of the interveners. Now might be a convenient time to start that.
Well, why don't we, I know it's slightly earlier, but why don't we take our lunch break now? And then we can wrap up as we need to after lunch, and then the interveners would have an opportunity to ask follow-up questions. So we should come back at 1:40. Thank you. Off the record.
Thank you.
just heard from Zach, who had to change devices and therefore needs to be let back into the Zoom room. Thank you.
Okay, back on the record. Mr. Dean, Mr. Hazel, do you have some additional questions?
I have one sort of just technical question about how the substation works. It's not necessarily a noise question. Looking at figure 7-5 of the DEIR, and I noticed that there's the substation contains both iron core shunt reactors and air core shunt reactors. And I was hoping the witnesses could just enlighten me as to like what the difference between those two pieces of equipment are and what purpose they serve.
I can take that. The iron core shunt reactors are used for the cable compensation because of the high charging currents and natural capacitance in the cables. You need to offset that by using the iron core shunt reactors. And in this case, it's a lot of it's driven by size, Mr. Hazel. That an air core shunt reactor of that size would be significantly larger and probably take up a lot more space, just the way they're configured. Whereas the air core reactors, because they're smaller in nature and they're used here for the harmonics filtering, because the harmonics filters are a capacitive type filtering device, you offset the capacitance from the harmonics filters with a shunt reactor, and those use the air core shunt reactors.
Could I have just a moment, please, Dean? Just a minute. Thank you.
So it looks like from this layout that the iron core shunt reactors are more associated with 275 cables coming into the site, and the air core shunt reactors might be necessary for after the voltage has been stepped up. Am I on the right track with that, or?
Yes, you're absolutely on the right track. So the iron core shunt reactors, as I mentioned, are for the transmission cable compensation. So that would be the submarine cable at the 275 kV. The harmonics filters, which include the air core shunt reactors, are connected to the 345 kV bus because they are for power quality, for compensating for any voltage distortion just due to the nature of a long transmission cable system and converter-based equipment.
So the harmonic filters are in like the southeast corner of the site, and the air core shunt reactors are on the other side. But it sounded like you were saying those pieces of equipment actually are sort of serving a common purpose.
They serve a common purpose, but for different pieces of equipment, really. And I'm calling the cable a piece of equipment.
Okay. All right. Yeah, that's helpful. The last point I wanted to ask about was in the northeast corner of the site, there's a small building labeled 230 kV GIS building. Is that correct, or should that be 275 kV?
I don't have the exact drawing that you mentioned in front of me, but I would assume that that would be the 275 kV GIS building.
Yeah, we
Ted,
should
please
have
correct me.
relabeled that. So
Gotcha. I think it's clear enough from the transcript here.
Yeah.
All right, I'm all set. I was just trying to understand the difference between air core and iron core shunt reactors, and thank you, Mr. Aruda.
Does anyone else have, on the bench, have any follow-up noise questions? Then we would move to questions from the interveners. Ms. Damas?
Great, thank you. Thank you all so much. Just before I start, and I'd like to start with focus on the sound modeling, and hopefully I won't be repetitive in certain respects, but I just need to understand it well. But before we took break, Mr. Barton and Mr. O'Neill, you were asked a question about your exposure to substation transformer noise. And I'm just curious if either of you have lived next to something like what is envisioned here.
So the answer I gave to the question was my experience in my professional life, having visited quite a long list of substations and related facilities in the course of work I have done for utility and developer clients.
Okay, but you haven't lived next to a noisemaker scenario like this. Is that right?
Well, I gave you my answer, but no, my home is not in the vicinity of a substation.
Okay, and Mr. O'Neill?
Similar to Mr. Barton, I've visited many in my professional career. My house where I live is not located next to one, no.
Okay, thank you. So my first question, and as I said, I'd like to understand a bit more about the sound modeling. When you do this sound modeling, do you include a margin of error? Is there an industry kind of standard margin of error that you plug into these models? And what is that?
Got to unmute. So there's certainly a lot of conservatism built into many different steps of this model. And that really goes into what I would call a safety factor, or what you termed a margin of error. Yes. We can go through, let me just turn for a second. Here we go. To the methodology section, which is discussed in section 7.5.2 of the draft EIR.
Okay.
There's, I guess I'll start with all the equipment is operating, as we said, at maximum capacity, every single piece at simultaneously, which could happen at times, certainly at maximum capacity. Won't happen all the time. The other conservative assumption is the meteorological conditions that are assumed in here. And they're stated in the document of a temperature of 50 degrees Fahrenheit and a relative humidity of 70%. We use that in the sound modeling because those meteorological conditions provide the least amount of sound level reduction in various sound waves and different frequencies. So weather conditions that are different than that are going to have more sound level reduction from a source, and therefore the sound will be somewhat reduced from that. The final, I guess, two more things. The international standard that we use is called the ISO 9613-2 standard for propagation. Assumes conservative meteorological conditions as well, such as a temperature inversion. On top of all that, we did for this modeling include an additional 2 decibels of modeling uncertainty for this project. So I would suggest that there is a good amount of margin, if you will, in the sound level modeling results.
Okay, thank you. Am I right to understand that ISO 9613-2 in the section 7 has a plus minus 3 dB margin of error?
There is that section in the standard, and it does apply under very specific circumstances for certain distances and certain heights of sources. That's correct.
Okay, and so can you help me understand those specific distances? Why would they not be applicable here?
I do not have the standard directly in front of me. If we want, I can get the standard out. We can go through it. In general terms, as I said, we did include an additional 2 decibels of modeling uncertainty. And in one other conservative factor that I didn't mention, but I will now, is there's a ground attenuation factor, which is listed on page 7-15 of the draft EIR. That's an additional level of conservatism. We used a G of 0 for the entire site. What that means is we assumed that worst case, the ground was basically asphalt, a very, very hard reflective surface. That is certainly conservative. It's going to be largely crushed stone, which is not as reflective as asphalt. Therefore, when you assume a G of 0 or reflective, completely reflective surface, you're going to get an additional couple decibels of sound at your offsite receptors as compared to a G of, say, 0.5, which would be more typical for a surface like that, a crushed stone surface.
Okay. And have you been to this site? You know, there's a very deep ravine between the proposed substation location and, for example, receptor D.
And as you'll see in the discussion here of the modeling methodology, we did include the terrain elevation in the model. So yes, that was taken into account. Okay.
And then your mention of modeling temperatures at 10 Celsius, 50 Fahrenheit, and at the 70-degree relative humidity. And obviously sound varies in propagation with temperature and humidity. But you also mentioned there was that you taken a conservative approach. So I'm just curious, what's the less conservative data in that regard?
Well, less conservative would be using a different ground attenuation, would be using no safety factor. In other words, the sound levels we were given for the piece of equipment, we're going to assume those are reasonably accurate. Another thing is the comparison of the model results for impacts. We're using the quietest middle of the night L90 hour from January. And so if one looks at to evaluate impacts at really most of the rest of the year, you're going to find less of an impact.
Mm-hmm. And just a question, I mean, when you did those measurements, did you, on traffic patterns, I mean, Route 6 is a key noisemaker element here, I assume taken into account in the ambient. Did you contact Mass Department of Transportation to get actual vehicle counts, trucks, cars, et cetera, in those hours between 12 a.m. and 4 a.m. to support your modeling data?
I'm not sure I understand the relevance of the question. No, we did not contact Mass DOT, and there's really not a need to in this case because the sound level measurements speak for themselves. In other words, the traffic was what it was during that time period in January of 2020. And so the sound measurement equipment that we had out there measures the actual traffic, whatever it was. And as you can see from the figure in the report, I guess I direct you to figure 7-4. You can see there's a rather cyclical pattern to the sound level, which is repeated fairly regularly day after day, indicating a similar traffic pattern on the nearby roadways.
Okay, thank you. So back to the modeling again. I understand from the prior answers that the modeling itself was not based on the actual equipment manufacturing data, whether it's quieted equipment, custom for the project, or otherwise, but actual make and models and sound specification test sheets. So am I correct to understand that all of what we're talking about here and the conclusion that there's we're under the mass depth standard, assuming that's appropriate, am I correct to understand that this is really speculation at this point because specific equipment has not been chosen and modeling is not based on specific manufacturing information, at least in terms of proposed equipment?
I certainly am going to disagree with the observation that it's speculative. The sound level data that we have for each piece of equipment is based on the real world. It's based on real pieces of equipment used in other projects of a similar order of magnitude. So it's not fictitious or anything like that. It's based on typical, appropriately sized and commercially available equipment that we would expect to be similar in nature here for this particular project.
Okay, so when you say similar, are you referring to a similar substation? I'm just trying to understand what numbers you pulled together. Where did you get them from to do this modeling?
So we were certainly greatly informed by the previous Vineyard Wind substation project that was mentioned earlier, that was worked on a couple of years ago. That substation equipment, as we've talked about today, is similar in nature in terms of size, capacity, manufacturer. Yes.
Okay, has that equipment been selected and purchased, and is it in place, and has it been field tested?
Mr. Arruda may expand on my answer, but it is certainly not in place at this time. Construction has not yet started of the Vineyard Wind 1 substation.
That's correct. Construction has not started on the substation for Vineyard 1, but as part of our contractual arrangement with all of our contractors, they are required to meet the noise requirements stipulated by the project permits. So they have a contractual obligation to make sure they meet those sound power levels. So they need to purchase equipment that is in compliance with our permits. And then they need to demonstrate post-construction that the wind farm or the substation meets those requirements through real field testing post-construction.
Okay, so we don't really have a similar station upon which we're basing what we're doing here that's been field tested to compare the prospective modeling to the actual reality. Is that right?
So the manufacturers that supply this information, this is not their first project that they have built. They have, and again, perhaps Mr. Arruda can expand on this, but they have worked on other projects in other countries. So they have built this equipment and they have tested it and measured sound levels from their equipment. And those testing procedures are, again, based on pretty rigorous testing standards, IEEE testing standards. So I would suggest that the data out there is reliable. Absolutely.
Okay, forgive me. It's just that we don't have the detailed data on the modeling to look at to understand a bit better what numbers were plugged in essentially based on what equipment? Is it classes of equipment? Was it more specific equipment you've already got in mind? So it's difficult to, look at a model and have a sense of, can I really rely on this at this stage?
Again, I would suggest that we can rely on this. In general, every transformer and for every substation is ordered for the particular project, because there are very specific requirements for that substation and that transformer. You just don't go to a warehouse and pick one off the shelves. These are custom built for projects. That being said, there are very detailed testing standards that these manufacturers have to comply with, and we have a good track record of understanding how these perform as a function of their size.
Okay, so you plugged in specific equipment specifications, or did you just sort of do broader class specifications?
I would just say, Ms. Thomas, if you could point to specifically what numbers you are addressing or what values you're addressing, I think we would have a clearer record as to what inputs, if that's what you're looking for, you're specifically addressing here.
I think it's just generally based on doing a model and putting in, what exactly you're getting from manufacturers based on equipment that you're actually going to use. Instead of putting in, not knowing exactly what you're going to choose and putting in, numbers from a handbook. I'm just trying to understand at this stage what the modeling is based on. That's really my question.
Okay, I think I understand. I'm sorry, go ahead.
If you were about to say what you're about to say, then I will let you go.
I think I understand the gist of the question now. If you look at tables 7-3 and 7-4 in the draft EIR, there are a series of footnotes underneath the table, which give you a little bit, well, I'd suggest quite a bit more information about where the sound data came from for each piece of equipment. There were a couple of them that came from a Edison Electric Institute guide, that's called the EEI noise guide, again, which has a lot of engineering information. And most of the rest of them are, as you can see, models for a similar substation project or data provided by a manufacturer. So there are a couple different sources for the data, but they're very clearly laid out here in these tables in terms of what went into the sound model.
Okay. Thank you. And the EEI noise guide, am I correct to understand that is, it's not a guide that's going to set out specific equipment data specifications. It's going to class equipment into certain classifications.
It's an engineering technique that asks you what size piece of equipment. So in this case, what size is your transformer? Because the sound levels are largely driven by the size of the equipment. The bigger it is, generally the louder it is. So that in the absence of anything else, no manufacturer information, that is a very conservative starting place for us in terms of the rating of a piece of equipment.
Okay. And do these handbooks, just out of curiosity, do they normally contain disclaimers that, one should not necessarily rely on them because they are handbooks? They're not specific to the actual equipment to be used. Do you know?
I guess the way I'd answer that question is like anything in our profession, there's some professional judgment that has to go into gathering up all the sound information, putting it into a model, and presenting a result. And so we go through a very thorough process to gather that information and make sure it is conservative enough.
Okay. You're in your sound modeling, you did mention that you factored in, wear and tear and equipment tones over equipment life cycle. Obviously, what I'm getting at is brand new shiny machines tend to be quieter than ones that age over time. So I'm just curious how the modeling, in addition to the margin of error, which, as I mentioned, I understood it was +3, -3. Can you tell me a little bit about your reflecting in that model, the wear and tear and the equipment tones over the equipment life cycle?
So the manufacturers don't provide data on a piece of equipment as it ages, so I can't specifically comment on that. However, certainly Vineyard Wind is going to very meticulously maintain their equipment. It's in their own best interest, obviously, to have a well-functioning substation and every piece of equipment that goes into it. So they're going to do whatever maintenance is required. They have a very large investment here, so they're not going to sit by and let the piece of equipment start to fail. So I'm going to suggest that yes, as things get aged, some things may perhaps get a little bit noisier, but I'm not going to sit here and try to say this is going to get a lot noisier as it gets older.
Okay, thank you. I noticed in the reports it talks about, or implies at least, no resulting pure tones. How do you know that?
So the pure tone analysis looks at the various octave band data, and the Mass DEP has a very specific definition of a tone, where one octave band needs to be 3 or more decibels louder on either side of the adjacent octave band. And so using that criteria is how we came up with our conclusion that the equipment will not create a pure tone.
Okay, and the testing was under variable conditions. You mentioned, heat, cold.
The modeling was done under worst case conditions, everything running under the conservative assumptions that we talked about earlier.
Okay, but that was at a specific temperature and humidity level. It wasn't varying humidity levels and varying temperatures, right?
No, but it was at a very specific temperature and humidity for the reasons I stated earlier, and that those are conservative assumptions. If we started doing sound level modeling under different temperatures, different humidities, we're going to see a greater sound level reduction of the different octave bands.
Really? In either direction of temperature?
Some will vary in different directions.
Okay. Okay. Interesting. And you mentioned octave band, and forgive me, I'm new to the acoustical world. Is review of octave band data sufficient to identify any tones, or would the other the 1/3 or narrow band data be more definitive?
So there are certainly other ways you can slice sound data. The state of Massachusetts is very clear in the technique that we need to use to make that determination, and that is using the full octave band data.
Okay, but is the narrow band better I'm trying to understand if catching tones, if you're using the narrow band, you're more likely to have visibility of that.
So first of all, you can't use the narrow band technique on anything until it is built. You can't get pre-construction narrow band data, and it would only be post-construction, which would make permitting any source in Massachusetts or elsewhere impossible.
Okay, so again, I get a sense that we're using a broad octave band, and again, really what I'm getting at here is my client has a residence right next to what is being proposed, and noise is a considerable concern. So my questions are geared towards understanding, in fact, is the 8 dB really the maximum exposure here over time to my client? So that's where my questions are coming from, but thank you for answering that. I noticed you mentioned conservative quite a bit in your analysis. Just a general observation. I mean, if we're not talking about specific equipment for this specific site, can we really put any label of conservative or otherwise on what we're doing until we've specifically decided what we're doing with the equipment concerned?
I would object that to the extent you're saying we don't have a specific site or a specific equipment or a specific layout that we are assessing.
Well, let's say the equipment itself hasn't been chosen and purchased. So to say we're conservative when we haven't even done something is just a bit odd to me. So another question for you, Mr. O'Neill, and thank you for answering all my questions. Have you ever modeled a substation of this type? And then after it was built, engaged in a comparative analysis of what your modeling was versus what the actual results?
We have done some work like that over the years at different substations. Yes.
Okay. Anything substantially similar to this project?
What do you mean by substantially similar?
Well, you know, in proximity to residences, as we have here, the size of the substation, what's envisioned for the equipment, similar.
Certainly plenty of them. Yes. Yep. Plenty of substations are located in vicinity of some residents. A lot of the pieces of equipment are the same or similar. You know, there's a little bit of uniqueness here in the sense of there's an undersea cable coming into the station, but a lot of the pieces of equipment at the substation are very similar to ones we've measured at traditional land-based substations, which is what this is.
And you yourself have done measurements before and after to confirm your before numbers were in conformance with what came after in actual field testing?
Different members of my staff have, yes.
Okay. I know that you had said that, and we had pointed to table 7-4 and the notes thereunder, and that we're coming at this with 3 ways to generate this data for the equipment. One based on similar substations. Secondly, I understand some manufacturer specific equipment data is reflected. And thirdly, we have information coming from the EEI, correct me if I get it wrong, EEI handbook. So let's talk about the similar substation concept here and how that was leveraged to be reflected in this model. Have any of those other, or that substation concerned, I'm curious what substation it was, but also does it involve barrier walls like what's being proposed here?
Certainly some of the substations that we worked on involve barrier walls, absolutely, and some don't. You know, a recent example of the Vineyard Wind 1 substation project also involves some barrier walls, yes.
Has that wall been built?
As we mentioned earlier, that construction of that substation has not yet commenced.
Okay, helpful for me to know if, you know, your experience on other barrier walls at projects that are actually built with the wall up.
Yeah, that's not something I can rattle off the top of my head. There have been some. I have to circle back and get that information.
Okay, thank you. And are they similar in those scenarios? Are they similar in terms of the distance of the residences to the wall as what's being proposed here?
I can't answer exactly. I don't recall exact distances from the substation walls to the nearby residences, but very often if you're putting up a wall, it's to reduce the sound. So there's residents in the vicinity in the area. but I can't give you exact distances.
Okay. Do you or does anyone know in the VW team the distance of the noise making equipment in the proposed project to my client's residence, and my client's at a D receptor? So the distance from the equipment, also helpful from the outer exterior of the wall, the proposed wall, to my client's residence, exterior wall.
I might direct you to EFSB NO28, which provides a tabular listing of all the receptors and their distances and direction from the substation.
Is that the one that has 50 feet and I think 315 feet?
It's got a lot of numbers in there. I guess you have to be more specific than that.
Oh, because I didn't think it set out EFSB number 28, right?
Correct.
Okay, so I think we're at D, modeling location. So this is giving 50, it's approximate distance, 50 feet distance from nearest substation property line. And then we've got 315, again, it's approximation, 315 feet from the center of the substation. So what I'm asking is, do we have distance from the exterior of that proposed wall, which now I understand is 35 feet, to my client's residence? So not to the property line, from the exterior point in the wall to my client's residence. And then I'm curious, the distance from really the noisemaker elements most in greatest proximity are the transformers and the reactors on that west side.
I'm listening to you, and I'm trying to make sure I see which one is correct.
I don't know if Presiding Officer Sharkey, please correct me if I'm wrong. Can we get a record request on something like that? Is that possible?
If you have a specific question that they can't answer, or you wish additional analysis, all you have to do is
thank you.
Term the question and we will make it a record request.
I'm sorry, could you restate the question? I might be able to answer it here without a record request, if you don't mind.
Yes, I'd like to understand the distance from the exterior of the proposed 35-foot wall to my client's residence. And then I would like to understand the distance from the interior part of the wall to that set on the western side of transformers and reactors.
Sure. I think we can get a lot of that information from EFSB NO29, parens 1, close parens. It's got the substation layout, all the equipment is labeled, and I believe your client's house is not labeled as D, but if I look at another figure that has it on, I can see what I believe is location D that you're talking about. And this map is at a scale. I'll stop and let you get there.
EFSB number 29, you say?
Yes. There's a figure that goes with that response, which I think might be helpful.
Okay. And it shows that exact distance that
it's to scale, and I've got my ruler right here. I want to tell you the distance.
okay.
But anyone can measure that distance using this figure.
Okay.
So the distance from that 35-foot wall to the closest point on the house is approximately 110 feet.
Okay, thank you. So just another question regarding this distance aspect here. Have you looked at, in the mix, I know there were alternative sites. Have you looked at alternative sites that had greater distance between the envisioned location of the substation and any nearby residences?
I'm going to defer to one of my colleagues in terms of alternate sites for the substation.
Yeah, I could answer that. At an early stage of the project, we did a comprehensive review of potential substation sites and looked at numerous potential properties. And as you probably know from this general understanding of the real estate market in Cape Cod, as well as the build out of the Cape, is that there are relatively few properties of sufficient size generally along the route from our landfall site to the interconnection point. And so during that process, we did evaluate other sites and ultimately selected this one. And there, some were within residential areas and within similar proximities to residences.
Okay. Okay, thank you. So I just have a question regarding information request EFSB number 30. You mentioned the ISO 9613-2 sound modeling. And I'm curious, is that model sophisticated enough to handle modeling of multiple barrier walls, such as what's envisioned in the project?
It is. It is the software that, and this is where the software becomes very helpful. This would be something incredibly difficult to do, to try to do by hand, but the software does look at multiple reflections. It has the ability to take a source of sound, take it up to a wall, either go up and over the wall and or reflect off the wall. So yes, it can handle multiple barriers.
Okay, thank you. And when you ran the modeling, did you first do the modeling without this wall that you're proposing?
That would be standard practice, is to start there without walls, and then you see where things go, and then you add noise mitigation. And
what were the results without the barriers?
I do not recall.
Are we able to, am I able to ask for a record request for that information, please?
So as record request JJ-1.
A record request what?
JJ-1.
Thank you. And has the modeling been done on the basis of inclusion of absorptive walls for that 35-foot wall?
I'm sorry, I'm still taking notes on your record
Oh,
request
I'm sorry.
here.
I'm sorry.
That's okay. I just want to get it right.
No worries.
Okay, I'm ready. If you don't mind repeating your question.
Yep. So the modeling that you did you also do modeling that included absorptive walls, you know, for the proposed 35-foot wall?
No, we assumed hard surfaces.
Okay. And you mentioned having experience with other substations that had, you know, these kind of barrier walls. have you done sophisticated sound modeling and showing the mitigation that results from in those other projects?
Yes, we have. We use these same techniques, the same ISO 9613-2 software to do those other projects as well. Yes, we've done the same approach.
Okay. And did you also then, or is it a part of standard practice to do post-construction tests to determine how accurately your predictions were?
It is generally not standard to do that. Certainly, if a permit or a regulation asks for it, and we're asked to go do it, then we'll absolutely go do it. Yes.
Is that something that might be an assurance for this project?
I can't speak for the company and make a representation for the company's behalf.
Okay. I'd like to move a bit over to talking about the mass depth standard. So assuming the increase here will be no more, forevermore, than 8 decibels, won't that nevertheless be disturbing to my client and the others at the residences to the west? During the critical hours, one needs sleep.
So the answer is no, and I'll tell you why my answer is no. If you look at the sound level impact at location D as in David, I think that's your client's residence we're talking about. So the sound level at location D, if you look at table 7-7 in the draft EIR, the worst case model sound level at the outside of that house is 39 decibels. So the sound level reduction, you may have heard the conversation this morning about sound levels being reduced from outside to inside. So even with your windows open in the summertime, the sound levels are going to be reduced at least 10 decibels, generally 10 to 15 decibels from outside to in. So that would take that 39 decibels outside your client's home to 29 or less inside. And 29 decibels is extremely quiet, and that would not be a disturbance for anybody during those quietest nighttime hours where they're trying to sleep.
Okay. So you're saying that if I'm sleeping in a room facing the wall, and again, we have to look at the environment here. We have a ravine, a pretty deep ravine between where the substation is situated and then the ravine and then my client's property. So if, as most of us may like to, sleep with the windows open, you're saying that if you're sleeping, an 8 dB increase in the wee hours of the night is not going to have any potential negative impact.
I had to object to that because that is not what the witness just said.
Okay, but that's what I'm asking. I'd like to understand that because it's not.
Then
not
please phrase it as a
insignificant.
question as opposed to telling the witness he said something that he did not say.
Okay, fair enough. Will the increase nevertheless be potentially disturbing to my client?
So you have to realize that plus 8 decibel increase at 2 or 3 o'clock in the morning is outside. It's not inside. So unless you're sleeping outside, you wouldn't realize that plus 8 change. Inside, as I said, it might be a 29 decibels inside the house, which is again, very, very low. And that's a very, very quiet indoor level. If your refrigerator is running or anything's running inside, it's going to make quite a bit more noise than 29 decibels.
Okay, that again assumes that the modeling data, which we've established is not based on the actual equipment to be purchased, is going to in fact result in only that level of increase. So in that regard, I say we're being speculative in our information.
I'm sorry, but is that a question?
That's a comment. It's a comment. what additional attenuation measures will you take with this wall? Let's talk a little bit about the wall. I know we've talked a little bit earlier about absorption measures, but I'm curious about the wall. And it seems to me that a concrete wall has potential for a lot of sound to be refracting and jumping around. And I'm curious, is there any risk that sound within, particularly the U-shaped to the west, that sound is going to potentially leap over that wall and impact the residences?
So that is why the walls were designed with 3 sides and the open side facing away from the residence at the west. So any reflection that does have is reflected away from the residence. Now, there will of course be some sound which is still transmitted or gets over the top of the walls, and that's what we show in our modeling results. That is whatever's left over is that, small amount of sound is coming over.
Mm-hmm. Okay. And I mean, you mentioned it was a conservative approach, taking a poured concrete slab reflective wall, but wouldn't it be a conservative approach to design a wall that had an acoustically designed wall with a product like sound blocks, or something that truly will absorb that sound and not refract it out in different directions?
And I may ask Mr. Arruda to expand on this a little bit, but there are well, the specific design, of course, is up to the EPC contractor ultimately. What we're saying here is that there are materials available that can do a great job of reducing sound from the different sources within the substation site from getting off-site. There will be these limits. It'll be up to the EPC contractor to ensure that whatever they design at the end meets or exceeds these limits. The burden will be on them. And that coupled with any kind of fire safety considerations around the transformers has to be taken into account. You can't just put anything in there. So there are some limitations on what you can do.
Mm-hmm. I'm just reflecting on your mention of it being conservative. It just seems to me that a really conservative approach will be one that builds a concrete wall that has absorptive materials in the design, so that when that sound comes off those shunt reactors and those transformers, it's actually absorbed into that wall, and you reduce that refractive effect that's going to occur.
Again, Ms. Dahmus, I think I would agree with Mr. Garson that if you have a question, you may wish to phrase it as a question, even if you're drawing conclusions from some of the answers that he's providing you.
Fair enough. Thank you for the correction. So my question is an absorptive designed acoustical wall a more conservative approach than the wall that's proposed, the concrete wall?
Actually, it's the opposite. So this is a conservative approach by using the reflective walls. And I guess if I could add the technique here for predicting sound from a substation, that's really what we're talking about. This is not new. This has been done for decades now here in Massachusetts and other places with similar techniques. The issues are pretty well understood. The sources of sound are well understood. There's a good body of evidence, and these are the best tools we have to predict sound from a project before it's built. It's how really any of these projects are designed and permitted, is we have to use good data and make our predictions, and that's what we've done here.
Thank you. So I noticed in the documentation and the petitions that the zoning exemption is based on this being substantially identical factual and legal circumstances. Is that the case here, at least where my client is concerned? If we compare the Vineyard 1 and Vineyard 2 projects?
Ms. Thomas, I'm not sure that I understand the question, which makes me concerned that perhaps the witnesses may not understand the question as stated.
Okay, we can skip that. What assurances do we have in the event of future substation changes, and change does happen, that any ambient measurements taken at such future time will not include what you're saying is the maximum 8 decibel increase as part of the measurements made?
I'm not sure I understand the question.
So if in 2 or 3 years after the substation is built, if there's additional changes to the substation and the noisemaker elements increase and there's new sound measurements taken at that time, are those new sound measurements at the ambient going to include the increase that's happening because of the proposed project?
I guess I'll start by answering. I'd welcome some help from my panelists, but I think from what you describe, that would be a change to the project. So the company would have to come back before the appropriate regulatory authorities to get permission to make those changes.
Okay, thank you. In the operational noise analysis, I think it's footnote 7. No, I'm sorry. In the operational noise analysis, page 7-10. And I just noticed that that footnote does specifically state specific equipment manufacturers will be selected later in the project development process. I'm just curious, why was that put in a footnote? And my second question would be, in the full paragraph on the page, the middle paragraph, at the very end, it makes mention of exclusions from the model. It would be helpful to have your feedback on that. What was excluded?
I would ask that we try to keep one question at a time for the witnesses. It's just challenging to recall the precise questions and then answer to.
I'll take a stab at the first question, which I believe was, why did we put footnote 7 on page 7-10 of the draft EIR? Why was footnote 7 included?
Well, it seems an important statement to me in, doing an analysis. I just wondered why it wasn't up in the main body, given that it's stating that specific equipment manufacturers will be selected later in the project development process.
Well, we felt it was an important enough piece of information that we included it in the report.
Okay, thank you. And the last part of the last sentence in the full paragraph in the middle of the page, it talks about exclusions from the model. Could you please elaborate a bit on what was excluded?
don't recall exactly what was excluded, but this is, again, fairly routine for doing any kind of sound modeling. Since decibels are logarithmic, sound sources that are 15, 20 decibels lower, quieter than the loudest sources are really immaterial. They're not going to make any contribution to the sound level modeling. And so I don't have the specifics off the top of my head about what was excluded, but they had to be very minor sources. Again, the company wouldn't leave significant sources out of the model. They want to understand what the future sound levels are going to be, and they want to include all the important major sources. So the omission of some minor ones doesn't change the conclusion here of the sound modeling.
Thank you. May I have a record request on that?
Sure. Could you just state your questions specifically? Because
yes,
I'm just not clear from the transcript at the moment what
Yes.
you're asking.
Yep. So the sentence is other electrical and mechanical components of the proposed substation, either in the site yard, in the stat comms, or contained within site buildings or engineered enclosures, are assumed to be insignificant sources of sound in the community and were excluded from the model. So my question is, may I have a record request on what was excluded from the model in more detail?
Okay. So that would be record request JJ2.
Thank you. Am I correct that quieted equipment, it does appear to be the case that quieted equipment is contemplated in the equipment for the station? And I understand, correct me if I'm wrong, that quiet equipment is really custom made equipment to specifications that you desire?
That is
correct?
correct. That is correct. Yes.
In the operational noise analysis, page 7-11, it mentions further measures of potential noise attenuation. My question is, what assurance do we have that quieter measures set out will indeed be included in the substation build and final equipment selection?
I'll start, and perhaps my panelists could expand on this, but the sound level modeling that you see, and that's represented here to the siting board, relies on these noise control measures, the quieter equipment and so forth. If the company were to somehow ignore them for some reason, then the modeling is going to look very different. So the way I understand they contract this equipment is they're going to require the contractors procure equipment that meets these specifications.
All right, and then just one last question. Have you ever, has your modeling ever been found to not be credible by a court of law?
No.
Okay, thank you. That's all I have.
Thank you.
Does anyone have any follow-up questions on the testimony we've just heard? In that case, Mr. Gerson, would you like a break before you do
Ms.
redraft?
Sharkey, looks like Mr. Young has a question.
I apologize, Mr. Young.
I wasn't here when I wasn't visible when you asked the question. I have a question to the company. If afterwards the company or the state or the neighbors wanted to see whether the facility was was meeting the predicted 7 dBA or so at a particular spot. If you just went out with a meter, you would just get an ambient, including the substation noise, right, Mr. O'Neill?
That is correct.
So is there any way, operationally, mathematically, whatever, to answer that question after it's in operation?
The only way you can really answer that question, Mr. Young, would be to go out there at a similar time that you found the quietest nighttime background. So you want to try to minimize contributions from other sound sources. And so you would go out, and we do this, you'd go out at 2 o'clock in the morning and take some sound level measurements and compare them to, for example, table 7-7 in the draft EIR, which has the total sound levels in there, which is composed of, as you say, the ambient background plus the contribution from the substation. And if your total sound level is less than or equal to that number, then you should feel really good that the project met that. If it's above it, then you've got to figure out whether the background is different that hour or not. If the background has changed, something else going on, and then it may get a little more challenging to figure out if you can turn that source of sound off, which generally you cannot turn substations off.
All right, so that's what you would do first, is you would try to pick a time where the ambient of that year was as similar as you could get to the ambient that's in your DIR or wherever it is. And that's the main way to do it. So if you were in an area that was, developing rapidly, in some sort of highway location with lots of new stuff, then it gets harder to do that. Is that right?
That is correct. And that's why you're usually out there at 1, 2, or 3 in the morning to try to minimize those contributions.
All right, thanks very much.
You're welcome.
Can I ask one clarifying question? Mr. O'Neill, can you help me understand why a concrete panel, which is reflective, is preferable to maybe like a softer surface, which I'm picturing the insides of a sound booth, which are like padded. Can you explain like why a concrete surface is actually the best, as you had indicated earlier, compared to something else like that might look more absorptive?
Certainly. So you used the example of a sound booth, which is a good example. So it's really frequency dependent, and conversation, like in a sound booth, is at a higher frequency. So different materials will absorb that differently. In the case of a transformer or substation related equipment, a lot of the energy is in the lower frequencies. And so you need a material with a lot of density. I'll call it a lot of oomph. Hope that transcribes okay, Mr. Brock. Something with a good amount of mass in it that's going to stop the transmission of sound through it. Because no matter how tall you might build a barrier, if your material does not have enough mass in it to stop transmission through it, then the height doesn't matter. And that's why concrete panels or a material similar to that is often preferred for these types of sources.
In the past, I've seen, I'm aware that at construction sites, temporary noise barriers will be erected. And is it true that temporary noise barriers have that look of being like a more padded surface?
So those temporary noise blankets that you see around construction sites, that's a very different form of noise control than what we're talking about here. Those provide a lot less sound level reduction because they're they're much thinner. They don't have the same mass to them as a concrete panel would.
Okay, thank you. That helps me understand the differences.
You're welcome.
So, Mr. Gerson, would you like, do you have redirect, or would you like a break to assess whether you have redirects?
We will have some redirect. I expect that it will be short, and I would appreciate very much a short break so that we can make it as short and efficient as possible.
Then why don't we take a 10-minute break?
That
Mr.
should be
Brock,
fine.
would you like 15 minutes, Mr. Brock?
10 minutes is magnificent.
Thank you. Off the record. So let's go back on the record. Mr. Gerson, do you have redirect for us?
I do have a few questions.
Please proceed.
Mr. O'Neill, earlier today, you were responding to a question about forms of noise mitigation that could reduce substation noise impacts. Do you recall that?
I do.
And so I'm going to read from a transcript of your response and ask you if there is a correction that you would like to make. So in response to questioning, you said, and I will go back to the point that we did make earlier in the conversation today about the comparisons that we're talking about here are to just 1 or 2 quietest nighttime hours in January. Really, the impacts that we're talking about are much less reduced for most of the rest of the year and most of the other hours during the days or the evenings. Would you like to make a change to that testimony?
I would. I got twisted up in some double negatives, I think. Really, the sentence I would like to correct is, it should read, really, the impacts that we're talking about are much less for most of the rest of the year.
Thank you very much. So just a few additional questions. Do you consider the modeling that was done for noise from the substation in this case to be speculative?
No, it is certainly not speculative.
And are the inputs to the sound modeling that were used in this case consistent with standard practice for noise modeling for substations?
Yes, they are.
And do you consider the noise modeling that was done in this case to be conservative?
Yes, I do.
Are other substations permitted without the make and models of equipment within the substation being specified?
That is, excuse me, that is exactly how they are permitted, yes.
Thank you. That's all I have.
Any recross or questions on redirect? In that case, I believe we have a very limited number of questions on safety. And then we will wrap for today, since we will be returning on Monday to resume questioning regarding the substation. Ms. Yellen?
Hello, good afternoon, everyone. In general, can the company please elaborate on how it intends to, this question is actually related to air, but can the company elaborate on how it intends to minimize air quality impacts of the onshore cable construction?
I think we may have touched on some aspects of this earlier, but the onshore cable construction of necessity uses a standard complement of construction equipment and an excavator, a couple of dump trucks, some paving equipment, some other trucks and support vehicles. So a lot of what we talked about on another topic about moving the work efficiently and quickly will also serve to minimize air pollutant emissions from those trucks. So the quicker you can safely do the work, the less time the equipment operates, and the fewer emissions that there are. So at one basic level, that is how we would do that, and we would certainly be respectful of the DEP's no idling policy. We're not going to be using off-road equipment here, so their particulate matter requirement doesn't really apply in this instance. But those would be the things that would come to mind, and then at a sort of, most people wouldn't think of this necessarily as an air pollutant, but we'll also obviously try to maintain a clean work site so that there's not any significant fugitive dust being generated. So.
Okay.
If I could add to that, yes, I would just like to refer to the DEIR section 10.7.1, which I think expands on the point Mr. Barton was just making about good construction practices and best management practices to maintain the construction site in a good manner, to minimize any offshore and off-site soils or dust from leaving, keeping construction waste covered, sweeping the site of any dirt so it would not be transported off-site. And I think that section gets into some additional details that may be helpful in the answer.
Yeah, and I remember when we were talking about mitigating noise impacts, we talked about portable walls. By any chance, would portable walls aid in mitigating, air quality impacts? Just curious.
I don't think they make a difference one way or another.
Okay.
Presiding officer, and I apologize.
Nope, Mr. Gers.
But I would like to, Mr. O'Neill has had a busy morning. If we don't need any more noise questioning, I would like to let him go, if that's all right with you.
Mr. O'Neill, we will be sad to see you go, but you are excused.
Thank you very much, Presiding Officer. Thank you, everybody.
Hey, Rob.
Take care.
Are there locations where, based on knowledge of existing MCP, that's Massachusetts Contingency Plan sites, the company plans to complete soil or groundwater pre-characterization activities prior to duct bank installation?
I could speak to that at first by saying that the company does intend to carry out a phase 1 environmental site assessment for the final approved transmission route, and that phase 1 environmental site assessment is intended to identify areas that may require additional testing to characterize any potential recorded environmental conditions that you were just describing.
How would any of the information, so is the company collecting information related to existing MCP sites? Is there any data that is being collected on existing MPC sites related to this project?
We did do a screen for that at the routing stage of the project. So as we were looking at potential routes and route variants, we checked the DEP database for that kind of information. and it would have been plotted on some of the constraint mapping that we developed at that point. And if you want to look for it, I can take a few minutes and do that, but it is something that we looked at. Yes.
That's okay. The data from that, could it be used to improve soil or groundwater management procedures during construction?
Well, it depends on what you find. So in this particular case, if memory serves me correctly, what we found were relatively few reported sites, and those that were there had either remediation had been completed and they were closed, or they were some distance away from the route. So there was nothing, again, I'm doing this from memory, but nothing that would have particularly flagged an area of concern. There are other instances if perhaps you were working in a more urbanized environment and there were, more serious sites that came up in search, that might flag for you an area where you'd want to do a little more testing and checking before construction started.
I see. Thank you.
Mr. Barton, if I could have the witnesses refer to a figure from the initial petition, figure 5-23. I think that shows hazardous waste sites along the primary and noticed alternative routes.
I don't have my petition map book handy, but I have the similar maps were reproduced in the DEIR, and I'm just looking for the corresponding figure.
Oh, figure 10-1 in the DEIR.
Yes, thank you.
So it looks like along the primary route, there are two different symbols, one for a activity use limitation and one for a chapter 21E site. In those specific instances where there's documented hazardous waste sites along the primary route, would the company complete any pre-characterization prior to duct bank construction, just to have advanced knowledge of how soils or groundwater might need to be handled during construction?
With the caveat that we would obviously look at the documentation first and see what that told us about the nature of the spill or leak in the first place. What was done to address it? Was the cleanup completed to DEP's satisfaction, or is there anything active still underway that would tell us we needed to go out and look a little harder at it?
So it sounds like. Go ahead, Mr. Rodstrom. Thank you.
No, I just expand a little on Mr. Barton's comments. As I mentioned, similar to Vineyard Wind 1, we would take the analysis that's presented in the DEIR and the siting board petition that identifies those sites, do a further comprehensive phase 1 environmental site assessment study, which would include specific recommendations for phase 2 site characterization if necessary, and that would be done by a licensed professional, and that we would then conduct the site characterization based on those studies.
Okay, so it sounds like if sampling were to be carried out, it'd be done as part of a phase 2, and then results of that sampling might be used to inform construction planning. Am I on the right track there?
That's correct, and it's essentially a deeper dive into the analysis done to date, verifying, as Mr. Barton said, whether any past remediation had been carried out, documentation of the same, the extent and proximity of those sites. As I recall, those sites are not directly within the roadway layout, but I'd have to double check. But that would be the comprehensive study done on the entire transmission route that would focus clearly on the 2 sites we've already identified, and then pursue any site characterization in the field with field testing if needed.
Thank you. I'm all set, Ms. Yellen.
Moving on a bit, if the company can please refer to EFSB-S-2. For the record, can the company please define what URAM regulations are, or what URAM provisions are, please?
So the basic definition is embedded in this response. It's a utility-related abatement measure. So this is a program that was essentially designed to allow utility work to occur in areas where there might be some contaminated soil, to deal with it correctly and responsibly, but do it in a way that doesn't require the whole project to come to a halt for weeks or months while more detailed studies are done.
Okay.
And this is it's standard practice for in-street work.
Okay. Help me understand how it relates to the MCP sites, to the Massachusetts Contingency Plan sites.
Chris, can you offer any more specifics on this beyond what we've already said in the answer?
No, I'm afraid I don't have anything further to add.
Okay. How do the URAM regulations allow the company to treat contaminated soil encountered during utility line construction?
Could we have that question read back? I didn't quite catch that. I'm sorry.
That's okay. I apologize. How do the URAM regulations allow the company to treat contaminated soil encountered during utility line construction?
So my understanding is that as a general matter, if the crew is proceeding with excavation in a particular location and they come across soil that appears to be discolored or has a particular oil or gasoline odor, for example, you would remove and segregate that material and then follow the steps that are outlined in the URAM protocol. So it's a way that in advance the crew and the supervisors are prepared to deal with this if they encounter.
Okay, so if contamination is encountered, the company must follow URAM protocol?
Exactly. Yeah.
Is the company able to describe a little bit about what that protocol entails if contamination is encountered? You know, what are there? I'm sure there are many steps, but maybe there's a general overview of what that might look like.
I don't want to prevent Mr. Barton from giving a general overview, but I would just say that there are specific regulatory provisions. They are rather intricate and technical, and we can certainly provide the regulations for the record. That said, I do not mean in any way to cut off Mr. Barton from trying to provide a helpful overview.
No, that's I think if the board is interested in the sort of the next layer of detail on this, it's probably something we should take as a record request and consult with some members of the team who can elaborate on it. But Chris,
if I could just add that in section 5.4.10 of the petition, there is a fairly good description of the active use limitation sites, and also discussion of the URAM provisions and the type of measures that would be taken to manage those contaminated soils if encountered.
I guess one thing I'm interested in having a more general explanation of is how do the URAM protocols allow the company to handle soil differently than if you were just say building a commercial building, you know, just regular construction, non-utility construction. How do the URAM provisions allow the company to do things differently than if contaminated soil were encountered during non-utility construction?
I'm not sure we can offer a compare and contrast there, because our familiarity here is at least on this panel is somewhat limited to the URAM process, not the broader 21E that applies to commercial construction in general.
Okay, I'd like to issue a record request and have the company provide a general explanation of how following URAM protocols differs from what would otherwise be required if contaminated soil were encountered during construction.
That will be record request EFSB 36. And if the company has an additional witness who may have more experience in dealing with the details of the MCP during construction, could it please indicate that as part of the response?
I just have a final question about exclusion fencing. There is mention a bit of exclusion fencing, I think, in the analysis. For safety-related purposes, though, can the company outline and explain if there is any exclusion fencing for safety-related purposes for the onshore portion of the project?
If I could ask, are you referring to a specific point in the petition volume 1 analysis, or?
I don't have the specific reference. I don't have the specific reference right now, but is the company aware of any exclusion fencing that, is along the preferred route of the construction? Is there, whereabouts might the exclusion fencing be?
We also speak into where we would conduct the trenchless crossings, meaning the HCD at landfall, the crossing of the.
I'm sorry, Mr. Aruda, I just can't hear you.
Are we also speaking to the HCD landing point at Craigville Beach, the crossing of the Centerville River, and Route 6?
Yes, please.
If so, each one of those locations would have fenced-in areas for safety purposes to make sure that no one could get into those areas where you would have operating equipment or things stored and things of that nature. Those would be the primary areas along the route that we would have exclusion fencing in there for safety purposes.
Okay.
And if I could add, I do believe the site design plans do include reference to the fenced-in perimeter of those construction sites that Mr. Aruda alluded to, including the substation site for the work zones that would be established at the onset of construction.
And how would the company maintain, a safe work zone for in-street construction to prevent the public from encroaching on the workspace?
During the in-road construction, we will be working with the town of Barnstable on police details for traffic management and things of that nature, along with having our construction managers there and the contractors managers. And one of their roles will be to maintain a safe work zone at all times.
Are there any, I guess I'm interested in the physical measures that might be put in place around the limits of a work zone to make sure, say, that a pedestrian doesn't, wander into an active construction site where there's an open trench or something like that, or a bicyclist, or, any number of people using the street.
Sorry, I was on mute. As I mentioned, there will be police details or flaggers or whatever the town police department determines appropriate for this. But there'll also be signage. There'll be cones and safety barrels along the way to let people know that this is a cordoned off area at which, residents of the public are not allowed to enter during the construction process, along with the personnel on site that will be tasked with making sure that people do not enter into that zone.
Thank you.
And if I could just add, it maybe goes without saying that the company does adhere to standards for all workers within those zones to wear personal protective equipment, the necessary reflective gear, hard hats, and safety equipment to ensure those within those zones are also working with the necessary safety equipment.
Thank you. That concludes my set of questions.
I have a general safety question. This has come up a few times in some previous projects and also again in Mr. Axelson's questions. There seems to be a public perception or presumption that electrical equipment may explode or catch fire when flooded. Could any of the witnesses explain if this actually does happen? And if so, under what circumstances? Or if not, what makes transmission and distribution equipment different from these other equipments that they're referring to?
I can't speak to other projects. I'll speak to this project as far as infrastructure that will be underground. It is designed and built to withstand being submerged in water. I mean, everyone knows the basic concept, water and electricity do not mix, but these components are specifically designed and they are meant to be in an area that can be in water if necessary, because everything is sealed against intrusion of water for that obvious reason.
Thank you, Mr. Ruda. And that includes everything in the project, including the substation, or are you just talking about the nearshore equipment?
I'm speaking to the nearshore and the onshore duck bank route where you have vaults where splicing will take place. I'm not speaking to every component at the offshore on the onshore substation because that's an above ground structure in an area that I think is highly unlikely that you would end up with equipment there submerged. But I was mainly speaking to the landing and the route.
Thank you, Mr. Ruda.
And just to add, I think it's clear in our filing, but the design does utilize a XLPE transmission cable, a solid state cable, insulated cable.
Thank you, Mr. Rostrom and Mr. Ruda. I'm all set with that question.
Does anyone else on the bench have additional questions? Then I suggest we conclude for today and resume on Monday at 10 o'clock. I hope everyone has an excellent weekend, and I'm anxious to see all of you again in the morning on Monday. Thank you.
Have a good weekend.
Thank you.
Thank you, presiding
Thanks,
officer.
everyone.
Thank you.